Hello, hello, Muskan. I'm audible.
Yes, I can hear you.
Great. Suraj. Dear participant, we we are going to start very shortly. Yeah? Within 5 minutes, we are going to start shortly. I request all the participants, please be patient. Hello, Muskan.
Hello.
Usman, I think that uh, we can start. So I think that our eminent respected guest is also there. Uh, Anuj ji, Ishan ji, Ratnakar ji, they all already joined. I'm audible perfectly. I'm audible
Yes, sir.
perfectly. I'm audible.
Yes, sir.
So I think that we can start
Okay, sir.
because we have to adhere the guidelines.
Yes, yes, sir. So, good morning, everyone present here. I would like to take this opportunity today to welcome you all in the inaugural ceremony of ATAL Online Faculty Development Program on Internet of Things with Artificial Intelligence, organized by the Department of CSE, Chandigarh College of Engineering and Technology, Digreeving, Chandigarh. Thank you all. We are truly delighted with your presence. Main objective of adult academies is to plan and help in imparting quality and technical education in the country and to support technical institutions in fostering the research, innovation through training in various emerging areas. I, on the behalf of everyone present here, heartily welcome Dr. Sunil Singh for an inaugural note. Over to you, sir.
Muskan, thank you. Muskan, recording is on. Recording is on. Recording is on. Just please confirm. Because whatever we are doing, we have to record each and everything and submit to the AICT. So no issue, Muskan, because firstly, so I understand it is
Yes, sir. Yes, sir.
uh, it is on.
Yes, sir.
So now again you have to start. It is already started.
Yes, sir.
So please mute. Uh, very good morning to all of you. Today, a respected guest from the world-renowned industries, dear Mr. Ratnakar Madanji, Data Product Manager, ASML, Netherlands, world-renowned leading industry in chip manufacturing and supplier of Intel. Muskan, please just mute. I request all the participants, please mute your mic. And dear Mr. Ishan Agrawalji, Senior Software Engineer, Microsoft India. Dear Mr. Anuj Duggalji, Developer Relations, Google India. Respected R.K. Soniji, Director, Atal Academy, and Regional Director, AICT New Delhi. Respected Manpreet Singh Gujral, Sir, Principal, CCT Degree Wing, all the HODs, faculty members, and dear FDP participants and other guests. On the behalf of Department of Computer Science and Engineering, I warmly welcome and invite you all in today's online inauguration function. I am extremely happy to welcome our respected guest from the world-renowned industries. I'm delighted to just say that I'm very thankful that all the dignitaries, all the respected guests accepted our request on a very short span of time and agreed to honor this FDP inaugural ceremony. I feel privileged to welcome all the esteemed participants in AICT Training and Learning Academy, AICT New Delhi. This FDP is sponsored by AICT on Internet of the Things with AI from 12th to 16th July 2021. I am very happy to announce that this FDP received a very good response throughout the country. I am very happy to share that all the seats, all the seats of this FDP, that is a 200 seat, that is a maximum limit, is full in a very small span of time within 10 days. So this indicate that all the participants are keen to take out some good things from this FDP and many of them are in waiting list. So we feel sorry that we could not accommodate the waiting list. It is also the matter of please to share this information with all of you that in this FDP we have the participation from the 17 state of India. So it's a very good thing. It's a very honorable thing for all of us. The main objective of the ATAL Academy is to plan and help in imparting quality technical education in the country and to support technical institutions in fostering research, innovations, entrepreneurship through training in various emerging areas. Yes, in this FDP, we have a 14 session, and in the 14 sessions, we are covering introductions to IoT and its applications, cloud computing, distributed computing, machine learning, its application in healthcare sectors, data science and applied AI, application and challenges of smart sensor in IoTs, AI powered for IoT devices, IoT with Raspberry Pi, Arduino practical sessions, and there are many other things which will try to accommodate all the things in these 5 days. One more information, I think that every participants aware about these things, that in this FDP, 80% attendance is mandatory and 60% marks, which will be done in the last day in the form of quiz. So any participant is eligible for the certificate from the AICTE if he and she will score 80% attendance and 60% marks in quiz. So I request all the participants that please adhere these suggestions and guidelines. The objective of this FDP is offer to an excellent opportunity for academicians and the faculty member to get knowledge, expertise, and training on IoT and AI. Dear participants, I promise that you will enjoy the learning of this FDP and the kindness of all the speakers and the organizer from CCP. Hope this FDP will play an important role to enhance our expertise in IoT field. So once again, on the behalf of whole Department of Computer Science and Engineering, Chandigarh College of Engineering Technology, Degree Wing, Chandigarh, thanks to AICTE for sponsoring and giving the opportunity to host this FDP in online mode. So with this word, let me thanks once again to all the respected dignitaries and the participants. Thank you. Have a nice day and happy learning.
Thank you so much, sir. Now, moving forward with the program, I heartily welcome the eminent guests for today. Firstly, I would like to invite Mr. Ratnakar Madan. He is a product lead with experience in deep tech B2B products in diverse industries like semiconductor manufacturing equipment, automotive, and healthcare. Currently, Mr. Ratnakar Madan is a data product manager for ASML EUV products based in Netherlands. Before this, Mr. Ratnakar Madan had the opportunity to lead AutoStream, which was world's first map streaming service to enable multiple levels of automated driving. Welcome, sir.
Just to check, am I also audible?
Yes, sir, you are audible.
Yes. Ratnakar, you are audible. Yeah. Now your camera is also on.
Good.
That's good. Please, Ratnakar, over to you, please.
So I would like to first thank Dr. Sunil, or how I like to call Sunil sir, for inviting me here. I'm also thankful, or rather humbled, to Dr. R.K. Soni and Manpreet Singh because of just the opportunity to join you all as faculty in this inaugural ceremony of the faculty development program. Personally, I've always been more inclined to reason about why rather than what and how of things. So I've always focused on why. That is why today I would like to share with you my thoughts on why I think the topics of this development program, IoT and AI, deserve your utmost attention. If you look around you, India is expected to cross China's human population by 2027, meaning that India would be the most human populated country in this world. Most of our demographic will be young and a tech-enabled demographic. Mobile phones, smartwatches, think of any other technical enabled devices, these digital devices, these are everywhere and reaching to far beyond limits of the cities of our country. So they are really getting into our rural areas. On the other hand, we are also going through a pandemic, which will push us into to developing new infrastructure. Right, to come out of this pandemic, there will be a huge acceleration on spending on the infrastructure. Combining these two, the young demographic and the young infrastructure, we will have a huge India of things, or as I call IoT. India on things will be by far the largest data generator in this world. I think you need to pause for a couple of seconds and really digest this. The size of this opportunity is immense. Again, India of things will be by far the largest data generator in this world. On the other side, we hear data is the new oil, right? It's the next generation oil. This data combined with artificial intelligence is already and will continue to disrupt every sector and every domain in India, be it old non-tech based domains. Think about governance, think about finance, banking. Every sector will be disrupted by data, IoT, and artificial intelligence. This disruption will lead to the next generation of tech giants, which will be key contributors in India's growth to a 5 trillion economy and much, much beyond. You, the faculty, have the power to steer and enable this multi-generational change. And you have the power to accelerate India's growth pace by sowing the right seeds in the curious mind of the students. With this, I hope that I've triggered your thoughts, your interest in these topics. I wish you all lots and lots of learning in this development program on India of Things and AI. Thanks a lot.
Thank you. Thank you, Rupna. It's very enlightening for all of us that you have given your valuable time to us. And we are very happy to listen your word of wisdom. And definitely the participant will be benefited from these word of wisdom. Muskan?
Yes, sir. Thank you so much, Ratnakar, sir, for encouraging us with your words of wisdom. Now, I would like to invite Mr. Ishan Agarwal, who is currently working as Senior Software Engineer at Microsoft India, where he has worked on various products like Outlook, Microsoft Teams, Kaizala, and more. He has more than 10 years of experience in this industry, and prior to Microsoft, he worked with Adobe, Samsung, and Ericsson. Welcome, sir.
Yeah, hi. Thanks, Muskan. And good morning, everybody, all the faculty members who are present here. And special thanks to Professor Sunil, sir, for inviting me here for this talk today. Thanks a lot, sir. So I want to just start by saying that I have been in this industry for past 10 years, and for the past 5 years, I have been associated with Microsoft here. And what I have seen here is a change in the industry where each and every product which we work here in Microsoft, we are all moving, bringing some AI and ML inside each and every product here which we are working on. Now, you can consider every, like the Teams, Microsoft Teams, which on which we are doing a video conferencing, Microsoft Outlook, or any product which we work on. We are bringing more and more artificial intelligence and AI, so that our users and our customers get most out of this product. So like, just take an example, like in it's in Gmail or Outlook. When you start typing that email, then it gives you the suggestion that, okay, by what the context, what you are writing on the email or anything which you are writing, it have the context that what you are about to write, and it gives you a suggestion to auto complete that email, so that you become more efficient. You write email more efficiently, you have auto correction, you don't make mistakes there, and it makes your life easy. So all these so ML and AI is all about making your life easy and getting more out of the product which you are using in your day to day life. And in my in here where we are all encouraged in Microsoft to take trainings on ML and AI, so that we all learn those things more and more, and bring these capabilities in the existing product, so that we can make best out of it, so that our users, our customers, or everybody can use that product more efficiently and bring most of it. And it's not and I have seen this change not in IT industry. It's not about only in IT industry. You take any industry like automobile, manufacturing industry, where this shift towards ML and AI are increasing day by day. So if you take an example of Tesla, means you have the car where you have all the sensors there. You just go sit in the car, and the car and you just put your destination, and the car drives you automatically by sensing each and every vehicle outside, and it also maintains the ambient temperature of inside the car and everything. So this is all possible. This is only possible with ML and AI, which keeps track of you, what you feel, and gives you a personalized experience of the product, so that you feel more comfortable to use that product or anything which you are trying to use, and can make most of that. uh, One more example which I can take is that Amazon have opened these stores, some of the grocery stores in the US, where you just go, you just scan your mobile, and your Amazon account gets scanned, and when you try to shop any of the product, you pick the product one by one, or you keep the product outside, so it automatically knows that you have taken this product, and it will deduct that amount automatically from your Amazon account, or from your credit card which you have given, and there is no queues for checkout. There's no queues for for payment. So it's a very smooth experience, and it saves your time. So time is money nowadays. We have very less time, so everything, so it helps you out to get most of from your day to day life, so that it makes your life easy going forward. So with that means, I want to say that I want to encourage all the faculty members to pass on this message to all the students, to enlighten them, and give and say that there's a shift in industry, that coming 10 years would be of ML and AI, where there will be a need of engineers, like all the students, which will help create this next generation product for each and everybody in the industry. And it's in every industry. It's not about IT. It's an automobile, manufacturing, any industry which you talk about. Yes, there is a need of ML and AI and all, and it can only be possible with the help of all the great faculty members which we have here, which you can enlighten each and every student to help help grow themselves as well, and the products which everybody is using and making a difference in the life of each and every people who are using that. So yeah, so thank you, thanks a lot, sir, for this. Yeah.
John, thank you so much, Hassan. Thank you so much that you have accepted our request and taken out some time from your busy schedule to create this program. And your contributions definitely, your encouragement, your word of wisdom definitely help us a lot to move forward in these technologies. And definitely, these are the faculty development programs. So faculties are encouraged. Definitely, they are making the future of our nation. So definitely, your suggestion will help them to give more step up towards the students. And so, thank you so much, Isan. Thank you so much. Thank you so much. Yeah. Muskan, please.
Thank you so much, sir, for encouraging us and enlightening us with your thoughts. Now, I would like to invite Mr. Anuj Duggal. Anuj Duggal is currently working in a developer relations team in Google India and leading the Google for Startups Accelerator and Google Developers Expert Program. He is a champion leader and is on a mission to inspire, enable, and empower people to innovate and build something impactful, making this world a better place. He has also been a mentor for change and an inspiration to innovators community in Chandigarh, India. Welcome, sir.
Okay, thank you. Am I audible, Muskan?
Yes, sir.
Okay, thank you, Muskan,
Yes,
for the wonderful
definitely.
introduction. Sure, and thank you, Sunil, sir, for inviting me here. Really happy to be here, and it's my pleasure to be in such a room where all the dignitaries are here and all the teachers are also here. Just a quick confirmation, if you can let me know, can you see my screen? I am sharing my screen.
Yes, sir, it is visible.
Okay. Good. So let me just present a few thoughts which I have, and probably I'm not sure. Sunil sir, are you able to see my screen as well? Just a
Yeah, perfectly. Yeah. I'm able to see. Perfectly.
Great. Okay. Okay. Thanks a lot for inviting me here, and hello everyone, whoever is present here. It's my pleasure to be here. I am Anuj Duggal from Developer Ecosystem Team at Google. I would like to tell you a brief about myself, and it'll be an honor to share like what exactly I am up to. I am very creative. I am an engineer by qualification. I have a master's degree, but at the same time, I am very creative. I do all these creativity on wall paintings or probably calligraphy sometimes. I am adventurous as well. I don't stay back. For example, I just travel. I travel to different locations, probably in India, outside India, and experience the world in a very different way. And I am innovative as well. Like if you see the drone flying and carrying a tire tube to save a life of a person affected by a tsunami in Andaman Islands, or the second photo that you see helping Indian Army do a mission-oriented drone kind of a system, or the third that you see going in Kolkata and enabling students to build aircrafts on their own just in one day. So all these things, if you see, I have done in my career span. I have also been very fortunate to work very closely with Intel and Niti IO, where we have set up these utter tinkering labs in the past. And these labs are basically to help students come forward and tinker with electronics, probably build solutions with IoT, and have AI machine learning running on top of it. And these are the things which I have been doing for quite some time now. And very happy to say that Sunil sir have been an integral part of this ecosystem from last 2-3 years already. And before I jump into the IoT, today's topic, which is IoT plus AI, I really want to take a moment and say and acknowledge that we are going through a lot. We are all going through a lot. And believe me, this too shall pass. And we are in this together. We have been seeing the world moving differently. There are huge shifts which have happened over the past couple of months, but we all have to make sure that we stay safe and stay healthy in this. Don't worry, we are all doing it together. Uh, Ishan and Ratnakar have been really wonderful in telling about the industry trends on how the things are moving in the IoT field. I am also going to present three thoughts and probably move to three different stories, which will be really helpful for you to kickstart this faculty development program and keep you charged up for the next five days. The world is going through a digital transformation. You see, a lot of things are happening because of COVID as well. We never thought that we will be sitting online and probably taking this course. Education has always been face-to-face kind of a delivery mechanism. We have never thought that online can be one of the modes where we can actually deliver the education. And there are multiple other things which are happening with the COVID thing. Smartphone users in India are expected to reach 760 million by end of 2021. And we are talking only for India. 760 million users in India are going to be on smartphone. And today, India, we are talking about mobile first market with so many people. And Ratnakar has already mentioned that we are going to be like leading, by 2027, we'll be leading the human population as well. I want to leave you with the thought that, just think for a moment, this photo, there's a person who is sitting probably in Himachal somewhere, and this person probably, affected by COVID. What is the first thing that comes to your mind? How would you help this farmer? Let's say that this persona is of a farmer. How would you help this farmer? You don't have to answer it now, but for the next 5 days, keep this thought in mind that, what will you build for this particular persona? And I'm not just talking about this persona. There may be multiple personas which you would have seen in your life, but just think about this person. And probably there is a problem to solve. You may come across a problem which a farmer is facing. And that problem can be related to farms. It can be related to the data that crop is not yielding the right product, or probably anything else. And similarly, those problems which are there, make sure you solve for local first. Don't think about global problems. Don't think about solving problems of United States. Think about solving problems of Punjab and India first. So start local and then go global is one of the things which you definitely want to address. Start with your regional level, start with your national level, and to solve the problems. The photo on the right you see is one of the engagements from our Google communities where they have solved a problem for police folks during the election time, and they have been mapping all these areas where the election is going on. The second thing which you can think about is opportunity to lead. Identify the challenges you have and probably the attitude and behaviors while preventing, and just imagine that how empathetic you can get for a particular user. Today we are talking about IoT and AI, how we move forward. Over the next 5 days, you are going to go through the different courses of what are the things that you will learn over a period of time. It can be cloud computing, it can be IoT, it can be AI. And tomorrow, it can be whole new set of different technologies. But just make sure that you are empathetic enough to understand the user of how this technology is going to help a user. And that is where there is an opportunity for you to become a leader. You will become a leader by solving someone else's problem, by becoming a leader in yourself. Let me ask you a question. Which superhero inspires you? Feel free to unmute yourself and call out a name. Probably I can wait for 5 seconds. Anyone wants to volunteer and come forward and say which superhero inspires you? Yes, D, you are saying something? Okay.
I request from the participants, please act that this is one of the very greatest opportunity that what you feel inside, please share. Maybe something amazing come out from the Anuj.
Absolutely, feel free. And probably over the next 5 days, you will be having more interactions like these.
Yeah.
It's an online session. We have to make it interactive. Which superhero inspires you? Anyone who wants to answer? Probably five answers in the room.
Excuse me, sir. Myself, Anand. I'm inspired by the character Shaktiman.
Shaktiman. Oh, wonderful. Great. Anyone else?
Dear Anuji, my superhero is my mother. So that's
Okay, wonderful, very nice. Shaktiman, mother. Okay, one more.
Hello,
One.
sir.
Yeah.
Tayal Naik, sir. May I answer, sir?
Yeah.
So my superhero, I always believe my dad is my superhero.
Got it. Okay, great. I got 3 answers. Thanks a lot, Anand and Siva, Thayalagi, Siva Kumar, and Sunil sir. So superheroes are, Shaktiman, mother, and dad. Definitely, they are definitely superheroes. Probably these are also the superheroes. If you see Wonder Woman, Iron Man, Batman, and bunch of other people you see on the TV screens, and probably Shaktiman as well. These are definitely, we have grown up seeing them as a superhero, and probably we have seen our mothers and fathers as well of how they have been superhero in delivering education to us, on probably learning anything, imparting any knowledge to us. But one thing which I really want to tell you today, that I want to tell you who is my superhero, and my superhero is you. You know what, you have been the teachers, and it's not easy. You are superheroes in yourself. You know why? Because superheroes do building and growing together. Building and growing together is a superhero stuff. You have been building the students, you have been growing students from day one of your job, and it is a superhero stuff. Helping someone to learn a skill is a superhero stuff. Helping someone to get success is a superhero stuff. Acknowledging efforts is a superhero stuff, and rewarding contributions from the community is a superhero stuff. And you have been a superhero all throughout. And for the next 5 days, you will be learning a lot of new technical things, so that you can go back and impart this knowledge to the students and become another superhero for students in IoT and AI. And I want to leave you with 3 stories. One is this Jeff Bezos. You must be thinking why I have projected this person. He is the richest man on earth, right? And why I'm projecting this story, I want to tell you a story here. Be kind to yourself and others. When this person was traveling, he has quoted this in one of the articles he has written. When he was traveling with his grandparents and he was watching his grandmother basically smoking, and that's when he started calculating. He's a very smart person. He started the calculation. Okay, how many moments of her life she will lose by smoking every day. And then he came up with the calculation, okay, hey grandma, if you are smoking like this every day, you will lose 10 years of your life. You will die 10 years early. He's the smartest person, richest person on earth. And his grandma just listened and stayed silent. His grandfather came forward and said, it's okay that she is doing that. But one lesson which I want to learn for you today is, it's very, very hard to be smart, definitely, but it's even harder to be kind. I know that she's been doing, and it takes a lot for her to get out of this, but I'm very kind to her. I'm very kind to her to understand that, this is a challenge, and probably we will get her out of it together, but it is taking time for her to come out of it. And probably he would have communicated this thing in a very different way, but he made sure that he's kind enough to deliver this message. So be kind to yourself and others is one story which I really want to leave with you today. The second story I have is with this person, the famous scientist we have. He has produced a lot, he has failed a lot, but not every time you will get success. Not every research paper he has written has gotten him the fame that he has been working on. Not everything that he has written has been a success. Probably there are a few things which he has just done for processes. There are a few things which he has done just small theorems, but he has produced a lot. He has learned a lot, he has written a lot. And probably over the next 5 days, you will be learning a lot, you will be producing a lot, you will be making projects a lot. But do not fear to do this. Do it, go ahead and do it. You may fail, it's okay, but you should go and do it. And the last story which I have is of these monkeys. These monkeys is basically, it's kind of a real experiment as well, that there are 5 monkeys in a room. And what scientists do is they keep a ladder. And there is a ladder so that these monkeys can climb and take bananas, which is kept on the top. And what happens is one monkey goes on the top
the MCQ
one monkey.
questions that we did in CO1. So CO1 हमारा हो गया, हमने फर्स्ट चैप्टर की रिवीजन भी कर ली, तो हम जितने भी
Okay.
क्वेश्चंस थे.
Hello, yes. Mr. Rajiv ji, please switch off your mic.
Yeah, sure. I think this is okay.
Yeah.
So last story I have is that there are 5 monkeys in a room, and there is a banana kept on the top. There is a ladder. One monkey goes on the top to get the banana, but what scientists do is scientists throw a cold water on the monkey so that he couldn't take the banana, and the monkey comes down. And you know what? The 4 other monkeys who were watching that monkey go and come back without a banana, they got scared. And you know what? Whenever another monkey started to go up to take the banana, and the other 4 will pull him down. Hey, there is a danger on top. Do not go there. And you know what happened? After that, the scientists replaced all the monkeys one by one. And by the time all the monkeys were finally replaced, not even a single monkey dared to go on the top and get the banana. But the story here is that, if a new monkey with a new thought process is coming, he doesn't know whether there is a cold water which is going to be splashed at him. There was no water which was splashed at him, but he has taken the assumption as the reality. My request to you is, do not take assumptions as reality. Challenge assumptions. If someone is asking you that it has to be done this way itself, challenge it. Ask them the questions. I'm not asking you to just go and violate all the laws. I'm sure you have to abide by the legal laws and the rules which are there in the country. But all the unofficial laws, you can go and challenge them, and make sure you go ahead and come up with different ways of producing a lot. And all the 3 stories that I have told you, make sure, be kind, produce a lot, and challenge assumptions. Thank you for taking this journey, and all the very best.
Thank you so much, Anuji. Very, very inspiring and very encouraging words and stories you have shared with all of us. And definitely these things motivate us. And as you suggested that we are the best hero ourselves, and definitely we have to just transfer this knowledge to the students and make them hero for the nation and make them hero for the future. So I'm so much delighted to listen your word of wisdom, and thank you so much, Anuji, for just taking out time from your busy schedule and honoring this inaugural ceremony and inspiring and encouraging us with your word of wisdom. So thank you so much, Anuji. Thank you so much. Thank you so much. Muskan. Hello.
Hello.
Muskan.
Yes, sir.
So just Muskan, I would like to update to all the dear participants, and now the guest of honor, Dr. R.K. Soni is a regional director and the director of ATAL Academy AICTE. But due to some unavoidable cause, right now he's traveling and try to connect, but he's traveling. Right now he's on the train, and that's why he could not join. But he convey his best wishes for this FDP, and he ensured that he will join in the coming sessions and to interact with all the participants. So on the behalf of Dr. R.K. Soni, I'm just conveying his best regard to this FDP. Now, Muskan, Principal Sir has joined. Principal Sir has joined. I think that Sir is trying to join. Before Sir is coming, I'm just looking out the. I think that I'm shared the detailed schedule of this FDP, and as I told that we have 5 days, and in all 5 days we have 3 sessions. On Monday, that is today, we have 3 sessions: session 1, session 2, and session 3. And session 1, basically, we have to discuss about the introduction about IoT and the applications. And the second session, artificial intelligence, opportunities, trends, and challenges. And the third session is IoT protocols and architectures. Now, on Tuesday, session one would be cloud computing, distributed computing. Then session next session, that is the session 5, data science and applied AI. And the sixth session that is to be held after the lunch, that is the AI powered IoT devices. Now on Wednesday, on Wednesday, IoT security and privacy. And then the second session of the Wednesday, that is application and challenges of smart sensor of IoT. And the third session, that is to be just, it is a mandatory that one session should be dedicated to the yoga and stress management. So that is a third session in Wednesday. On Thursday, there is a session 10, smart home and cities, that is a IoT computing. Then next session of Thursday, that is the application of AI in IoT. And then the practical session, that is a very important thing, that is from the industry person, that is an applied AI. That is the last, that on Friday, session 13 would be introduction about the machine learning and the application in healthcare system. Then next session, again the practical demo session, very important, that is the IoT with Raspberry Pi or Arduino, that is a practical session. And then this is up to the 14th session. And after lunch on Friday, we will have a online test, and this online test will be 30 minutes, and the number of questions will be communicated to you shortly. And just I request all the person that the 30 minutes it's a very firm. There is no extension of the time slots. And after completing the online test, then the submission of the feedback on AICTE, that is a ATAL portal. And submission of the feedback is very, very important, because this feedback is mirror for the organizer, for the AICTE to improve for the future activity. And then the validity session. This is the detailed schedule of this FDP, 5 days. Muskan, over to you.
Yes,
Just I think it's one ceremony is also going, because today the vaccination center is stabilized in our college. So the inauguration ceremony of the vaccination center is also going on for the students. So I think that principal sir is busy there. So Muskan, go ahead for the next. That is the next item.
yes, sir. We hope that the program will be a productive opportunity for all of you to meet and discuss various aspects of technology, Internet of Things, AI, data science, etc. Please do not hesitate to contact us if there is anything we may be able to help to you with. I welcome Dr. Sunil K. Singh for a vote of thanks to all the people present here. Over to you, sir.
So once again, a very good morning to everyone, to one and all present here in online mode. All the respected eminent industry guest of honors, and all the participants. It is such an honor for me to get the opportunity to thank you. On the behalf of Department of Computer Science and Engineering, Chandigarh College of Engineering and Technology Degree Wing, Chandigarh, I extend a warm welcome to the participants who are attending this online FDP. I would like to express my gratitude to all the esteemed delegates who blessed us with their presence and took out valuable time for your busy schedule to grace the program and contributions to make this online FDP a great success. Thank you for inspiring, encouraging us with your word of wisdom. The 5-day online FDP is fully sponsored by the AICTE New Delhi under ATAL Academy. The main objective, uh, the main objective of ATAL Academy is to plan and help in imparting quality technical education in the country and to support technical institutions for fostering research, innovations, and entrepreneurship through training in various emerging areas. And this FDP is the part of this vision and this path of AICTE. So my deep gratitude and thanks to the AICTE for giving an opportunity to this department for hosting this FDP. So I must take the opportunity to thanks Honorable Professor Anil Tisabudre, Chairman AICTE, Honorable Professor MP Poniaji, Vice Chairman AICTE, Honorable Professor Rajiv Kumarji, Member Secretary AICTE, respected Dr. R.K. Soniji, Director ATAL Academy, Dr. Girdhari Lalji, Assistant Director ATAL Academy. Further, I must extend my gratitude to our respected eminent guests from industries, from Microsoft, from Google, from ASML, who have accepted my request in a very, very short span of time and agreed to grace this occasion with their word of wisdom. So I have no words to express my feeling that how much I am happy that I requested all the dignitaries in the late evening of Friday, and now today is Monday. So I'm so much delighted. So Mr. Ratnakar Madanji, thanks to Ratnakar Madanji, Data Product Manager, ASML, Netherlands. Mr. Isana Agrawalji, Senior Software Engineer at the Microsoft India. Mr. Anul Dukalji, Developer Relations, Google India. Thank you all the respected eminent guests to take out the time from your busy schedule to grace this event. Thank you for inspiring and encouraging us with your word of wisdom on this essential day. I thanks to respected Dr. Manpreet Singh sir, Principal CCT Degree Wing, who always encourage and support to host such activities in the CS department, help to make every webinar successful. Thank you, sir, for this encouragement and support. I must convey my deep gratitude to all the speakers of this 5-day online FDP who have agreed to enlighten the various sessions with their knowledge. I thanks to Professor Ravinder Singla ji, Punjab University, Chandigarh. I thanks to Professor Madam Savitra Gupta ji, UIT Punjab University, Chandigarh. I thanks to Mr. Biswajit Nayak ji, Director, Advanced Analytical and Data Science, New Delhi. I thanks to Dr. S. Nagendra Kumar ji from the School of Computer and Information Science, University of Hyderabad, Telangana. I thanks to Professor R.V. Patel ji, CCT Degree Wing, Punjab University, Chandigarh. So I thanks all the experts, dignitaries from the academy, from the industry who have agreed to grace this FDP with their word of wisdom. I thanks to all the participants who have opted this online FDP for enhancing their theoretical and practical knowledge in IoT and AI area. I extend my gratitude to CCT officials, organizing team, volunteers for working hard for the past few days to make this webinar successful, especially Mr. Sudhakar ji, Ishan Chopra, Anshul Gupta, Maninder, and Kirti Agrawal. Thank you so much for act as a backbone for this event. At last, we extended deep sense of gratitude to all those who work behind the screen to make this program possible. Once again, thanks to each and everyone presented here and gracing the occasion. We wish all the participants for a good learning experience with a good health and long life ahead. And I pray the safety of every person of this planet due to this COVID-19 pandemic and request to each and every participant that they have to go for vaccination and take all safety precautions to prevent their near and dear from COVID-19. Thank you all. And once again, my deep gratitude to all the respected eminent industry guests who honored the today event. So with these words, thank you all. And we are going to start our first session within 10 minutes. All the participants are requested to join the same links for attending the first session of this FDP. So with these words, thank you. Thank you so much. Happy learning. Muskan, I think that over to you.
Yes, sir. Thank you so much.
Yes. Okay. हेलो मुस्कान, सर ने ज्वाइन किया? मुस्कान देखना एक बार। मुस्कान, प्रिंसिपल सर ने ज्वाइन किया क्या? मेरे पास मैसेज आया।
So I'm checking, sir.
मेरे पास सर का dear participants, please be patient, sir.
I am unable to see the name in the list.
Princess joined or not? Because Muskan, any update?
No, sir. I'm not unable to see the name in the list of attendees.
Sir is joined. Just just make मुस्कान, एक बार सभी को
Access officer.
सर ने ज्वाइन किया देखो, नहीं तो एक बार मेक सभी का अनम्यूट करके एक बार आप एक बार अनम्यूट कर दो।
Yes, sir. Done.
Unmute to all, please.
Sir. Done, sir.
Unmute.
Done, sir. I've done.
Hello.
Sir, good morning,
Hello.
sir.
Ajay, good morning. How are you, Dr.
I'm fine, sir. Fine, sir. Fine, sir. Sir, I'm audible, sir.
Yes, yes.
Yeah. Dear participants, our respected principal, sir, Dr. Manpreet Singh, sir, has joined, and I request, sir, please guide us and motivate us, and tell something about, sir, how to proceed and how to move, sir. Sir, over to you, sir, please, sir.
Good morning to all the participants. Thank you, Dr. Sunil, for giving me an opportunity to have some brief talk today to all the participants of ATAL FDP 2021 at the CCT campus. At the outset, I would like to thank our Honorable Chairman AICTE, Dr. Sastududde, and our Director, Professor Soni, Regional Director of Northwest Regional Campus of AICTE in Chandigarh, for giving us an opportunity to host this program by the Computer Science Department of CCT Chandigarh. And it's an initiative which is being taken by AICTE last year only, and it has become a huge success to organize FDP programs at such a mass level, which has already taken on record books for conducting FDP programs across the nation in such a manner that it actually has facilitated the motive of the AICTE, which is to spread the quality education. And that message is being spread across to all the institutes to conduct this FDP program and be a part of this great initiative by the AICTE. Apart from this, I congratulate the Dr. Sunil and his team for taking an initiative and submitting the proposal to AICTE to bring CCT on the national map and organizing this in a FDP program in an emerging area, IoT with artificial intelligence. So this is what you can say. I'm not able to join early in the morning as we just have launched a vaccination camp in UT Chandigarh. It's an initiative by the Department of Higher Education UT Chandigarh to vaccinate all the students by 15th of August, so that we can bring the students in a small set sizes to the campuses so that we can conduct the classes in a hybrid mode. And this is the initiative which has been taken. This is the initiative which has been taken by the Department of Higher Education, and the 3 institutes in Chandigarh has launched the vaccination camp. And I hope these are the 2 important components which actually can bring back the education back on the roll. In the last, I'll not take much time, Dr. Sunil, that I would like to say that the pandemic that the entire nation has gone through has actually given birth to new paradigms, and one of this paradigm is the online education, which has become a new normal for now, that this is the only way we can proceed further. And being from computer science, I would definitely want to mention that the technologies which are developed in 1960s, 1980s, 90s, and 90s, and you can say that has facilitated this classroom teaching to continue. Have we not been at this junction of the technology era, then would have not been possible to conduct the online education at such a large scale. Still, I feel personally, there is a digital divide, that today we still have a lot of students who don't have a privilege to have the internet connectivity in their remote areas, and they are not having the adequate devices in order to access this component. And this, you can say, this pandemic has actually brought the digital divide to the forefront, that there's a lot of effort needs to be taken by all the educational institutes across the nation in order to reduce this digital gap and make efforts at their own level in whatever way to spread this digital connectivity to each remote area, so that the education, the key component which actually has, you can say, that can transform our society, should continue. So with these words, I would like to say that I hope all the participants, we have good number of participants in this camp, in this FDP program. I congratulate Dr. Sunil for bringing this FDP to the CCT campus, and then also congratulate Professor Sudhakar Kumar, who is working in the background in order to make this program a success. I wish you all the best, and I feel that we would like to thank AICTE also for taking such a great initiative, which has made these FDP programs new initiatives across all the nations. Dr. Sunil, thank you very much for giving me an opportunity to join and to address to all your participants in this issue. Thank you very much.
Respected sir, good morning. Thank you so much, sir, for your guiding words and support to the Department of CSE for hosting this activity, sir. Sir, we all can do all such activity with your support, guidance, and motivation, sir. And we request you, sir, that your motivation and your support is to this department. Definitely, we will fulfill all your dreams, and what your expectation to the department will try to do, sir. Thank you, sir, so much, sir, for your motivations and word of wisdom to all the participants of this session, sir. Thank you, sir, for your joining, sir. Thank you. Thank you, sir. Thank you so much, sir.
मेरी तो 12 बजे क्लास है, तो मैं टेस्ट कर लूँगा। मैं हम ये थोड़ी आवाज नहीं बंद है।
Muskan, I think that just hello, Muskan.
Yes, sir.
So I think that we may proceed with the first session.
Yes, sir. We shall proceed with the first session. So today's first session is Introduction and Application of Internet of Things, which will be delivered by Dr. Sunil K. Singh, Professor and Head, Department of CSC, Chandigarh College of Engineering and Technology, Chandigarh.
Thank you, Muskan, for nice introduction about me. I'm just sharing my PPT. Please just confirm that it is visible to you or not.
Okay, sir. Yes, sir, it is visible.
Just it is visible.
Yes, sir.
Mute your mic. Uh, a very good morning to all the participants. I think that my PPT is visible to all of you. So thank you, Muskan, for giving the opportunity to interact with all the participants with the first session. That is the introductions and application of Internet of Things, IoT. In this session, we will define the IoT concept, understand what lead to its emergence, and overview recent technologies advances that make the IoT paradigms possible. We will also discuss the key challenges that must be addressed in order to build IoT system. Finally, we will examine the opportunities IoT brings in different applications domain. I think that all these domain is well justified and well conveyed by the today eminent guest, Anuji, Ratnakarji, and Ishan. And also highlight the key importance of sensor in IoT and the latest advancement and development in the sensor, which will be a game changer in the future IoT. So definitely have a great add-on in the people comfort. So ultimately, the basic objective of this FDP to add on the advantage, the comfort of the people. So it's a very interesting and very wide topic. So we have to just streamline the whole presentation. So for that, I have to just make an outline how to proceed, how to start, and then how to conclude the whole presentation. So just look the basic outline of this presentation. And in this, I have to start from the basic, that is what is the Internet of Things, why we require IoT, IoT origin and timelines, technologies that enable the IoT, technology roadmap of IoT, then the various IoT standards, framework, IoT enabler, and the components. So this is a complete package in which we have to start from the introductions, then discussing the IoT system requirements, origin, and we will then examine the specific technologies that enable the IoT, and in particular the technology roadmap for IoT. Then IoT standard, frameworks, enabler components, and then thereafter we will continue our journey overviewing the different ARM processor. The ARM processor is playing a central role in this IoT technologies or IoT devices and the application and its applications, and as well as the solutions and the IoT opportunities and the challenges. Definitely, we have to look into this one. We also discuss the future smart IoT, how it relates with the Internet of Everything. There is a word that is called Internet of Things. The second, that is the Internet of Everything. And then talk about the latest advancement and the development in sensor. That is a solely project by the Google. I can simply just say that which will be the game changer in the future IoT, and then finish with the discussion about the various future trends and learning in IoT field. So just let us start. So now, what is IoT? The term Internet of Things may sound complex, but in actually is a fair, simple concept to understand. The Internet of Things describe the network of physical objects, one of the things that are embedded with the sensor, software, and other technologies for the purpose of connecting and exchanging data with other devices and the system over the internet. IoT technologies basically employed to reduce the human effort and improve the quality of life. The basic objective, the basic things, how we move toward the comfort, how we move toward the quality of life. IoT also refer a rich ecosystem of the physical object that greater information about the surrounding environments and transmit this maybe possibly after doing the local processing to the other device or the cloud platform, but definitely by a mean, and that mean is nothing is your internet or network traffic. And then applications which are fed with the data collected, compute, and then response. And on the basis of the response, you have to take a action. So the term things in IoT refer to a wide range of items. These items must include the health monitors, environment monitors, connected cars, satellite systems, and you can see that I have listed the few things. Now, if you just take the example of smart building and home appliances, the things relate which is connected to the internet. That is your washing machine. Washing machine is the thing. When you connect this washing machine to the internet, and control the remotely this machine, that is the Internet of Things. So washing machine, TV, fridge, door, locks, light. And now when we talk about the wearable devices, your smart watches, smart glasses, rain cloths, smart city, traffic lights, parking system, dustbin, entertainment, TV, games. So we'll try to connect each and everything to the internet. And why we are trying, why we are running to behind to connect all those things. So it's because we want more and more comfort. Now, when we talk about the basic steps in IoT, so basically there are three key steps in IoT. As I told you that that is a one that is IoT devices, maybe comprised with the hardware and software, where you are going to collect the data, and then the second that is IoT hubs or the internet, where you collect and transfer the data. And the third, that is the applications, where you have to take the data, analyze the data, and after the analysis, you have to take the action on that one data. So, as I told you that IoT refers a rich ecosystem of physical objects that gather the informations about the surrounding environments, transmit this. Possibly, sometimes you have to do some local processing also, and after the local processing, then you have to send the data to the remotely to the or other devices or the cloud-based platform, and then the application for analysis. And on an average, just the data, it's a very important that I think that our speakers also told that the growth of electronic devices is much faster than as compared to the growth of population. And just a data that is a 127 objects. I think that 127 object, 127 things are being synchronized with the internet or with the IoT every second. So generally, in 1 second in this world, we are seeing that 127 objects are synchronized. So just see about the things in the world of technologies today. So now, talking about the definition of the IoT. So IoT defined by the various renowned organizations and communities. So when Internet Architectures Board, they define the IoT denotes a trend where a large number of embedded devices employ communication services offered by the Internet Protocol. Many of these devices, often called smart objects, are directly operated by the humans, but exist as a component in building or vehicle or spread out of the environment. Now, IoT also define their IoT, that is it's a global infrastructure for the information society, enabling advanced services by interconnecting physical or virtual things based on the existing and evolving interoperable information and communication technologies. That is defined by the ITU. Oxford Dictionary also defined the IoT, that is the Internet of Things. That is now, and the interconnections via Internet of the computing devices embedded in every object, enabling them to send or receive the data. So every organizations define in the same things Technopedia, but I feel that the IoT is a network of connected things, which also include people. The relationship between not only to things to the net, it's a people to people, people to things, and things to things. Means we are going to connect object to object. They are connecting object to people and people to people. So for a common man, with the IoT, more and more household items to be integrated with these sophisticated technologies to have with the comfort. Another that is a very important that why IoT? Why IoT? The IoT offers a new and innovative way to manage and monitor the remote operation. So ultimately, everyone wants to keep his eyes and ears in the remote places. Over the past few years, IoT has become one of the most important technologies of the 21st century. Now that we can connect everyday ordinary household objects like kitchen, appliance, car, thermostat, baby monitor, or sophisticated industrial tools which are connected over the internet or the embedded devices, seamless communication is possible between the people, process, and things. Why? Suppose that you are in office now. I'm in office. I want to see what is going on in my home, or just for the security purpose, we want to see the surrounding of the home. So we have a camera connected. The camera is a thing that's connected with the internet. And now here there is an application, and with the application, I'm able to see the various activities moving around my house. Same thing if I'm if I'm a businessman, I have running multiple businesses. It is very difficult to go each and every places and to monitor and to manage. But now a single person how manage more businesses. So definitely a single person how keep his eyes and ear at the remote places at his and her own business. So now from one place he or she can manage multiple locations business. So it is only it's only happened because of the IoT. So another that is something is very important. IoT is also reducing the cost. Data. That is something is very also saving the times. So that will be discussed in the later. So ultimately, the basic objective to enhance the visualizations and listening abilities of a person. This is something is very interesting. Now, another things as is in the figure that you have seen that IoT. How the IoT connected. So I think that with this figure you can see that each and every part. I think that nothing is left. But why we are going to connect? Why we are going to connect? So there are some points that is to take a better decision. When you take a better decision, definitely when you have more and more data. Another, as I told you, that the ability to track and monitor the things remotely. Another, lighten the workload with the automations. Now you have a lot of the work, and it is very, very difficult to perform each and every work by your own. So you have to make the things. You have to make the things smarter. That your machine would be able to work with the help of automations. So this is another that is an increased efficiency by saving money and resources. As I told you that we have to minimize the movement. And when you are minimizing the moment, definitely you are saving your time that will be devoted with the others, and also saving money. So and that is something best. That is it enhance the better quality of life, and many more reasons. But these are the very key reasons. So as I told that the IoT platform, as shown in the figure, that can help organization reduce cost through improved process efficiency. Asset utilization, productivity, and with the improved tracking of the devices, object using sensor connectivity, and we'll discuss in the coming slide that IoT is not a new terms. It came into the 1999 the first time, and earlier also. But why in current scenario IoT is more and more popular? I think that it's my personal submission that the connectivity play a very important role. Connectivity means how you are going to transfer the data, at what rate you are transferring the data, because if you have some delay in transferring the data, definitely the analysis part and the decision part definitely would be delayed, and that may hamper. So your connectivity should be very high, very reliable, and the speed should be very high. So they can be benefited from the real-time insight and analytics. So which would be help them to make more decision. The growth and convergence of data. I think that you definitely know about the big data, and so every moment we are generating a lot of the data. So the growth and the conversion of the data, processes, and the things on the internet to make us such connections more relevant and important, and creating more opportunity for the people, business, and industry. So just with this diagram, I can say that now nothing is left; everything is connected. Now, why IoT becoming uh, more realistic, uh, because item can be more functionality. Now the item have more functionality and becoming more intelligence. Item can be managed in a very easy way. More information become available, and now the things, because in IoT, embedded system play a very crucial, very important role. And when talking about the embedded system, so embedded chips are becoming more cheaper, cost effective. People can afford. It's small. It's very easy to handle. And another thing that is something is very important, that is the power consumptions of these devices. So these devices consume very less power. Most of the devices run on the operated through the batteries, with just a very small power required. So these things, these things give more realistic view of the IoT technologies. And another, that is the communication becoming faster. I think that everyone know about that. And today we have a 5G, and in 5G you can imagine the speed of communication. Now. How does an object become part of an IoT family? So, a number of features distinguish IoT devices from their physical entity that make part of a digital system or the process. By and large, smart objects rely on a hardware platform that has a small form factor and often specialized computing capabilities. So as I told you that now the computing power of an hardware in a small size is increasing. Another, that is have a multiple sensing and actuation capabilities. IoTs are frequently battery operated, and therefore the energy consumption during the operation is kept minimum. So consumptions of power is very low, and most of the devices can be operated through battery. Usually transmit and receive the information wirelessly. They are connected to the internet and maybe have a unique address. Their functionality can be reprogrammed and may be able to operate autonomously without the human interaction. So these things are very important, and because of all these things, the object becomes the part of the IoT family. So for an IoT family, I think that these properties must have in the things. So, in addition, we can say that the IoT devices may be able to operate autonomous, require no or minimal user interventions or control. For instance, just take an example of smart home heating, ventilations, air conditioning system that once configured, monitor the climate of a room, start and stop a heating unit when the temperature is of that exceeds certain threshold. So I think that now when you just talk about a heaters are so much intelligent. According to the room temperature, they can start heating, they can stop heating, and same things when you're talking about the ACs. So ACs are day by day are more intelligent. More intelligent means minimal human interventions. So how you have to just take more and more comfort. That's why I'm telling that I have been giving the better life to the human. So now the next that is something very important. When the IoT started or IoT origin, so the term Internet of Things was first used in 1999 by British technologist pioneer Kevin Edson. So we can say that IoT terms coined by Kevin Earthman, and he described a system in which object is a physical world, could be connected to the internet by a sensor. And Aston also coined the term IoT to illustrate the connecting radio frequency (RFID) tags used in corporate supply chain to the internet in order to count and track goods without the need of human intervention. That is the first where he just implemented the IoT concept. So today, the Internet of Things has become a popular term for describing scenario in which internet connectivity and computing capabilities extended to a variety of object, device, sensor, and everyday items. So we need an internet for things, a standardized way of computer to understand the real world from anywhere, from any place. Just have a look. Just have a look that the year-wise things. That is in 2005, ITU again have given their own definition about the IoT, and that what IoT vision in a greater detail, whereby a range of wireless connectivity options enable business consumer devices, as I told, that including the TV, fridges, car, etc., to communicate and control by the user, regardless of their location. So in 2005, IPO given their own definition about the IoT. Now in 2019, 2009, European Commissions they given their own IoT action plan. The opportunities were recognized by the European Commission, who gave a much broader scope to the IoT definitions, encompassing virtually any type of object having internet protocol address and hence being reachable over the internet. And for the first time, the possibility of closing the loop is clearly articulated as the IoT and action plan for Europe, and specifically mentions equator and the ability of the object to interact with the environment. So they have, of course, their own actions plan for the Europes in the IoT technology. Now the Cisco, the next, that is the Cisco points also involve that Internet of everything. Now they from Internet of Things to the Internet of everything. So more recently, Cisco added data and human dimension to the IoT definitions and articulating an even broader concept that Internet of everything. Definitely in the coming slide, definitely I'll discuss how the Internet of everything is related to the IoT. That would open up a new experience and opportunities for business and people. Now, this is the timeline. That is as per the report published in Forbes. The growth of IoT devices you can see here, and in 2015, 15.4 billion, and in 2017, 75 billion IoT devices to be connected. So you can imagine that the growth of IoT devices is much and much faster than the population. I think that I'm just going to share one very realistic example. When I was in 10th, on that time, people have one phone, landline phone, that is to be shared by the 10 family members. And I think that everyone aware that 30 years back, we have PCOs and we have a different time slot for the calling. In day, 1 rupee. So in night after 11 p.m., the cost is reduced by 1/4, that is 25% of the day cost. So it's people are more prone toward calling after 11 p.m. because on that time the cost was very less as compared to daytime. So one phone shared by the 10 to 20 family members. But now in today's scenario, in the family, 2 members have a 4 mobile phones. So just 30 years back, one phone shared by the 10 to 20 families. Now in one family, they have more or double or triple number of IoT devices. You just hide the remote. Children will not operate the TV. So just see the dependency and the popularity towards the IoT devices. Now, next, that is the IoT market size in terms of revenue. Definitely, when any technologies to be grow up, definitely revenue with this revenue is always the other side of this moment. So in 2020, the firms in IoT sectors is expected to have more 450 billions annual revenue. That is quoted by the Bain and Company. And 2021, the size of market of IoT, including the hardware, software, system integrations, and data services, is expected be 520 billions. That is again Bain and Company. This is the information from the Bain and Company. And $1 trillion is expected to be spent on the Internet of Things technologies worldwide. That is the Statica. And in 2013, the Asia Pacific is expected to be the leader for IoT, spending market share with the 35% rate. And North America is expected 27%, and European, Middle East, and Africa is expected 5% of spending market share after the Asia Pacific. And 2027, the market size of IoT is estimated to expand to over $2 trillion. So you just imagine that if this kind of the revenue market of IoT is, you can imagine the growth of IoT. So the number of devices and data, as I told that in 2023, 2025, 2025, and 25 again, because the data is changing so fast. So if you're taking about 2013, so maybe what we predicted and maybe actually is actual implementation of that prediction is maybe have a very huge difference. So 2013, a big increase is estimated. That is a 15 billion in machine-to-machine connections, and this was 6 billion in 2018. So the connected home appliances is expected to be 48% growth, and the total is end-to-end connections. In 2025, data collected from the IoT devices is expected to be 73 zettabyte. You can imagine the size of the data. And most of the data may be obtained from security and video surveillance, industrial IoT applications. So the major sections where we are seeing the IoT technologies, one, that is the industrial applications. There is a lot of applications going in industry side, home automations, and the surveillance. In 2025, 75% of 50 billion connected devices worldwide are anticipated to be connected to an IoT platform, and the number of IoT devices are estimated to be 75 billion by 2025. This is the estimation, but what will be happen after the 4 year maybe increase. And some researchers also put it is up to 100 billions. So we'll see what will happen. So now the IoT processes, as I told that in IoT, the whole processes are divided into 4. That is, you have to collect the data, then you have to communicate the data, and after communicating the data, maybe communicate the data over the cloud or the remote place, where you have to just have some applications, and on that application you have to analyze the data, and after analyzing the data, you have to come on some result, and on the basis of the result, you have to act. So why we are taking the data? Because we are performing some tasks, we are taking some decisions. Because as I told you that in earlier slides, we have more data means our decisions to be very precise. So this is the 4 processes, and now that is from embedded system to IoT. So IoT and embedded system, I can say that it is either side of an coin. So on is 1 trillion internet connected devices by 2035. So this is the projection by the ARM, and ARM processor play a very key role in the IoT technologies. Will take a touch of that one also. So IoT can be seen on evaluations of wireless sensor network, where the network is no longer dedicated to a single application. Instead, IoT provide a platform that can be accommodate a range of applications and devices that are easier to manage, like ubiquitous computing paradigm. IoT devices operate seamlessly, but in adding, now we are connecting more and more devices. We have more and more functionality, and we have more intelligent processing or intelligent capabilities. So, embedded system have played a essential part in revolutions of IoT, and scale is also a very crucial character of IoT, as it encompasses extremely large number of devices. So this is something which is shifting from embedded system to the IoT. Now, what technologies uh, that enable IoTs? So let's take a look at the technologies that have enabled the IoTs. To begin with, this advance in mobile computing led to processor and devices that have a relatively high computing power, while consuming little energy and thus being able to operate without main power supply for longer. So such devices include smartphones, tablets, and that's frequently act as a mediator between the embedded system and cloud infrastructure in IoT ecosystem. Improved manufacturing techniques allow for the production of smaller computing hardwares, richer sensing modalities, while at the same time reducing production cost. As a result, affordable devices now exist that send infrequent small messages that little data to the cloud or the other devices. And this is a case of wearable devices. I think that now everyone is have a small devices which can be wear, and that device is doing a lot of computing, lot of getting lot of the data and transferring the data and computing the data. So another, that is a car monitoring system and home appliances. Now, big data and the cloud computing services to process data from the sensor. I think that very amazing. That is, a cloud computing is you have to keep your data at a remote place. So one thing, now your data is secure, and second that is very important. That is how to manage this. So collectively, the plethora of IT devices will collect enormous amount of data that is referred to as big data. Store and processing such a vast amount of data require a substantial additional computing infrastructures, and many companies do not have the budget because the financial implication is always with there. Because as I told you that when you have such computing power at one place, then definitely you have to invest a lot, and so companies do not have a budget or prefer to invest or acquire or maintain dedicated server that can handle this stuff. So therefore, they rely on cloud-based services that can perform a range of functions on as needed basis. Second, that is battery. Second, that is advancement in energy storage is another key enabler of IoT. Small lithium polymer batteries, as they enable devices to operate without charging or battery replacement for a long period of time. And then another fast and more diverse standardized connectivity options. So I think that in current scenario, we have seen that various communication standard has been developed over the recent year, as well, that follow the different devices to talk to each other wirelessly. Effort has been made to keep message and signal overheads low to enable more efficient communication, and several connectivity options exist to suit the scope of different applications. And I think that now we have a different medium to communicate. Bluetooth will be medium range, short range Bluetooth will be, and when we talk about have a medium range communications, we have a Wi-Fi, cellular, and for the long range, LoRa, Sigfox, and WiMAX also. So these wireless technologies developed as an open global standard to address the unique need of low cost and low power wireless IoT network. And then the last, that is development resources. Nevertheless, IoT has been made possible by ever expanding number of resources available for the developers, including the standardized programming interface, messaging protocols such as message queue, telemetry transport. That is one of the very important protocols which will be discussed in my coming third session, that enables the rapid integration with the cloud. The emergence of languages-dependent data format, JavaScript object notations make interconnecting different types of system much easier. Building on these, so development communities play a very important role. I think that everyone is familiar about the Google.com, familiar about every day they are accessing the Facebook.com, every day they are accessing IBM.com, Cisco.com. So just type one more word before to that one: developer.google.com, developer.facebook.com, developer.ibm.com, developer.cisco.com. You will land up from their regular page or their services page from the developer community page, from where you get lot of the technical support, lot of the technical I can say that stuff or the libraries which help to develop an application, develop an project. So every companies, they are not keeping their knowledge with their own premise or with their own era. They are expanding, and I think that there is a world open source community. So in current scenario, open source community is so powerful, and I think that there is I'm just going to share that is the Linux, and just imagine in talking about the supercomputers. So top 500 supercomputers are used are using Linux. Is no supercomputer using any commercial product. So this is the power of open source community. So why the IoT or the era of IoT is growing day by day because of the development resources offered by the development communities or various organizations. So now just first IoT standards and the frameworks. Just a minute. So IoT standards and the framework. So there are several emerging IoT standards, including the following: IPv6, Internet Protocol version 6, over a power wireless protocol area, which is short form 6LoWPAN, is an open standard defined by the Internet Engineering Task Force, and this standard enable any low power radio to communicate to the internet, including 805 dot something, and the Bluetooth, low energy BLE, and J-Wave for the home automation. So basically, these are the protocol. BP is another protocol that is a low power, low data rate wireless network, and used mainly in the industrial setting. So when we're talking about the standards, and ZB is a base on the Institute of Electrical and Electronics Engineering IEEE standard 802, and the ZB alliances create a the universal language for IoT that enable a smart object to work securely on any network and understand to each other. LittleOS is a Unix-like operating system for wireless sensor network and one machine-to-machine service layer that can be embedded in a software and hardware to connect. Then the data distributed services was developed by the Object Management Group (OMG) and IoT standard for real-time scale and high-performance machine-to-machine communication. Then constrained application protocol for is a protocol designed by the IETF that specify how low power compute constrained device can operate the Internet of Things, and the long range wide area network is a protocol for WAN. So this is the various IoT standards, and we can say that second that these standards is setting to the set of rules for governing the whole IoT system, and these set of rules is nothing known as the IoT protocols. So now, another that is the IoT framework, including following it, and that is the Amazon Web Services is a cloud computing platform for IoT released by Amazon. Embed IoT, Embed IoT is a platform to develop as for IoT based on ARM microcontroller, and Microsoft Azure IoT Suite is a platform that consists of a set of services that enable user to interact with and receive data from their IoT devices, as well as perform the various operation over the received data and take a call. And then the Google Cloud, Google Brilio and VM IoT suite is a platform that rapid implementation of IoT applications. And then Calvin IoT, that is the Calvin, is an open source IoT platform released by Ariskin, designed for building and managing the distributed application. And then IBM Cloud, these are the very renowned IoT frameworks. And basically, when we talk about the framework, it is a kind of structure which support or frame for a particular set of rules, ideas, beliefs, which you use in order to deal with the problems or decide what to do something. So this is the basic, this is the model. So every organization have developed their own IoT model. So now IBM Cloud or IBM Watson IoT built on top of the IBM Cloud platform. IBM Watson is a mature, developer-friendly IoT platform with the strength in real-time analytical and cognitive computing. And Ka IoT platform. Ka is an open source IoT platform that published under the Apache 2 license. So these are the various IoT frameworks. Now, IoT devices characteristics. So IoT devices may be categorized by the following capabilities. Because IoT devices are highly specialized and they are basically designed to operate within the very specific environment. And the hardware for IoT projects vary widely. So there are key characteristics that are common to IoT devices that provide a basic of comparison when selecting hardware or software to configure a new IoT network or to develop or expand an existing one. So that is another, that is a data acquisition and control. That is where we have to just give sensor, and these sensors is basically a data acquisition system which access the data from the various means, is whatever the things available in the environment or taking the data from the environment, and then control and send to the remote processor. IoT devices require specific data processing and storage capabilities. These help to achieve the data aggregation, transmission, and analysis. Some IoT devices may process data directly, while other transmitting the data to the other device to gateway or the cloud application. So, another means first you have to sensor, which take the data from the environment, then you have to process the data, that is data processing and storage. Third, that is a connectivity, means internet connectivity, maybe short range connectivity, or long range connectivity, or medium range. So it depends on the connectivity. You have to use Wi-Fi, Bluetooth, RFID network, or low power wide area network. So some device that communicates wirelessly and some. And then the last is the power management, batteries and photovoltaic cells. That is a solar. So power management is a very critical factor, as I told many times, that for a portable and wearable IoT devices that rely on a wireless power source such as the batteries or the photovoltaic cell. So now that is a processor, that is something is powering the IoT computing. So at the end, we have to compute the information which is taken by the sensor. So as a part of CRN report, as a part of the CRN report, which is published in around June 2020, they have taken a look at some of the industry latest processor, namely processor that are specifically made for IoT. so that are expected to power future innovation in the industry. So these are the some few processors which are helping the IoT. So the first place that is R, Cortex M, Ethos, and Q. These are the there are many versions, but these are the three broader version of the R processor, which is made by the ARM introduced. So ARM introduced the new Cortex A series, new Cortex M series, and the Ethos and View series. And basically, these chips, this processor is mostly capable with AI and micro neural processing unit that can be paired with the Cortex to provide a 400 times greater machine learning performance over the previous Cortex version. And the Atoms is highly configurable and use advanced compression technique to lower energy use and reduce the machine learning model size. Now, the second one, that is a MediaTek, which is Microsoft. The MediaTek collaborate with the Microsoft in again 2020 to accelerate the Internet of Things solution, ensuring the customer to get IoT supply up and running quickly. The third, that is Intel module-based vision processing unit. Fourth, that is NVIDIA Jetson Xavier, and then the Keron, that is a US-based company, and basically Keron artificial intelligence system on chip is designed to provide a smart surveillance, security, IoT application with on-device, edge AI and machine learning. So all the latest technologies to be accommodated by this processor developed by the Keron KL520, and then AMD Radeon Embedded V1000. So AMD offer combine the benefit of CPU and GPU graphics processing on a single die for compute-intensive IoT applications like machine learning and AI. So these are the some renowned processors and based on the CRN report. Now, IoT enablers, that is something is very important. So, why the IoT is popular and why the IoT is growing day by day is much faster than expected. So, because of ubiquitous computing, low cost, high speed, and pervasive network connectivity, and widespread adoption of IP-based network, and Morilla continue to offer higher computing power at lower price with the low power consumption. So manufacturing advances permit cutting edge computing and communication technology to be incorporated in very small object. Rise of cloud computing, fog and edge computing, big data, machine learning, and conventional AI and analytics, and the fast development of gadgets that allow low cost consumption. So now the another key component. So the technologies that enable IoTs are technologies which play a key component in IoT. So mobile computing, that is a smart low power devices, that is smartphone and tablet. You can convert your smartphone into the IoT boards or IoT devices. That we will discuss in the coming session. So second, that is a little device and little data. That is a embedded device, example wearable or sensor, and a standard that enable internet scale, that is the communications, standardized networking, Wi-Fi, 3G, 4G, 5G, Bluetooth, smart browsers, JavaScript, HTTP, TLS, and so many things. Web and community-based development ecosystem enabled by the trust, that is an embed, one of the very important things that we need to discuss in HTML. So now when we talk about the mobile computing, so mobile computing technology is not limited to mobile phones only. Any other mobile devices with the comparable computing power fall under this category. That is car, infotainment system, virtual reality headsets, smart home gateway, and other things. So ARM Cortex A family of the processor is well suited for such devices as I told that the ARM Cortex-X processors are widely used in IoT. So now I think that yeah, you can understand the reason behind this thing. And this is because this processor offers substantial computing power with the very low energy consumption, both of which are vital for mobile devices. So ultimately, in current scenario, we want more and more processing power, but by investing as much as less energy. So minimum investment of energy, minimum investment of size, but expectation of the performance is very high. So it should be noted that mobile devices must be some kind of an operating system. Currently, the most popular one in the field are Android and iOS. So although there are alternatives such as some other operating system, Ubuntu's, open source, Linux and others. So this is the mobile technology. Computing, that is one of the key components of IoT. Second, that is little devices and more sensing and big data. So another enabler that the IoT that we must is reduce cost of manufacturing small devices that are designated to collect and transmit a small amount of data. Uh, this is something is more elaborative. Delivering to search insider, that is a deeper into the flow of information. We can distinguish different type of IoT architectures that can be employed to the internet network node with the goal of moving data from a network each device to the cloud, that is a server, where it can be stored or processed. So in all scenarios, a small sensor and actuators reside within the edge node that are usually smart embedded system powered, for example, ARM Cortex AMD series of processor. And physically, these devices can be anywhere around the home, in the city, even out of the field on a huge form. As such, wireless communication protocol is preferred to wired connection while transmitting the data from the edge to the cloud. So, depending on the application's domain, cellular network technologies, LTE, Bluetooth, Wi-Fi, and other wireless standards are employed. So, at the end of the network, server, usually in the cloud, are responsible for processing all the bit collected data from sensor, where appropriate, sending command to act on an information, synthesize or analyze possible actions, including the pushing notifications to the user or sending commands or any other actions to be taken after the installation of the system. So this is another component which is very important in IoT. Now the third, that is as I told that is a communication, and communication is very very important, and we have a communication medium through the Bluetooth, LTE, 3G, 4G, Wi-Fi. So I think that in the current scenario, the 5G is the fifth generation of the cellular technology with the very very high speed. So as I told that now why the IoT is popular, I think that the communications play a very very important role in the growth of IoT device, because now keeping your eyes and ear at the remote place. So now in my room, now here I am seeing the things in a very real time. So how you get the data real time of the remote places? So for that you must have a very strong high speed communications with the lower latency and better wireless services as compared to 3G and 4G. And I think that most of the houses, or generally in metros, everyone has the 5G network capabilities. And I think that in this pandemic, and because of this connectivity, we are connected. So 5G enable user to download, just taken a data, download 8 GB movie in about 6 seconds. Just see the speed of an 5G. So if you have a 5G network, hardly you will take 6 seconds to download a very high definition movie that is of size 8 GB. Whereas when you compare with the 4G, it can almost take 7 minutes, and 3G 70 minutes. So I'm just giving a very interesting figure with all of you, that just see how fast 5G. See how fast it takes to download a file size of nearly 4 GB. Okay. You have a 4 GB file size, and now 1G. 1980s 1G, one generation network, and in 1990 2G, 2000 3G, and then 2010 4G, and then 5G, and it just if the theoretical maximum limit is 20 Gbps of 5G, so a 4 GB amount of data, 4G amount of data would take almost 5 months, 40 years back. 40 years back, 4 GB data need 5 months to download, to transfer. But in today, just merely a 1.5 seconds. So see the growth, see the improvement, see the evolutions of internet connectivity and speed. And because of these things, we can place our ear and eyes at the remote places, because in my places we are seeing in real time same things. We want to see the things real time in remote places, and it only happened because of the network connectivity. And the fourth one, that is something very important, that is the ARM-bed, and another enabler of IoT, that is a substantial development resources. I request you all that you have to yeah here uh, cloud and community-based development. That is a embed. That is a another platform where provide the stuffs for the IoT development. So embed helps to accelerate the development of IoT devices by providing the C++ software development kits, SDK, a microcontroller hardware development kit, an integral development kit IDE, including an online compiler, online developer collaborations tool. The platform allows combining the different type of microcontroller, sensor, wireless technologies, and the software stack as the best meet requirement of a specific application. So embed platform used for an easy prototyping and development of an application system based on ARM Cortex M based microcontroller. So it provides the open software libraries, provide the open hardware library designs, and open online tools for professional for the rapid prototype of products based on ARM based microcontroller. So the web link of this os.mbed.com, os.mbed.com. So please visit, and it is a open source, and here you will get the 32 bits ARM Cortex M microcontroller as an IoT device. So just a very small that ARM processor across the IoT. So ARM Cortex A, ARM Cortex ARM family, and ARM Cortex M family. So application processor for feature-rich operating system, that is a third-party application, and ARM Cortex R family is for embedded processor for real-time signal processing and control applications, and then ARM Cortex M microcontroller-oriented processor. That is application-specific or the system-on-chip applications. And here you can just see the growth of or adoption of the ARM Cortex A processor. The performance of the ARM Cortex processor has increased dramatically for the past 5 years, and now here you can see that from 2016 to 2020, the acceptance, the deployment is 2.5 times. So here the application and use of IoT. So with the industry 4.0 and the Internet of Things, companies are now truly facing new industrial revolutions, and application scenario like smart home, self-driving cars, fridge that go shopping online are no longer that is stuff of the science fiction. So now here you just see that talking about the Internet of Things or the applications. So it touching each and every part is every day things to be connected, and for the smarter of tomorrow. Talking about the agricultures, definitely we are controlling, we are managing, we are improving the agriculture sector through the technologies. Again, IoT embedded system, the wireless connections, vehicle asset, Now even we can monitor our pet. We can through these technologies, through these IoTs, smart homes, smart cities, smart revenue system, as discussed by the eminent guest, Mr. Nakar Madanji. So every area is, I think that no one is area is untouched from the IoT. So what are the various opportunities? So I think that we discussed a lot. That is in automotive sector, fitness sector, portable wearable devices, resources management, industrial applications, machine-to-machine interactions, and the smart lighting, smart farming. So these are the various opportunities. And industries, manufacturing, transportation, agriculture, and consumer, smart homes and appliance, assisted living, and wearable devices, healthcare system, fitness and productivity. So these are the various opportunities, but every opportunities have some challenges. So when we talk about challenges, so the security, interoperability, and the standard, and the privacy, regulatory, legal, and right issues, and emerging economics and development issues. So security is one of the major concern of IoT because we are connecting the things remotely. How to ensure the robust and lifelong security in IoT product and services, and voluntary interoperability, the voluntary use of open and interoperable and widely available standard as a technical building blocks for IoT devices will deliver a greater benefit. So privacy is also how to regulate the whole things. It is also one of the challenge, how to stabilize and everything. And then the emerging economics and development issues. So in order to the benefit of IoT to be truly global, the unique need and challenging of implementation in less developed region, not only keep the things to the metros, we want to move the things to the every places where the development is not at the same pace at the metros. So we have to address each and everything, everywhere. So now, how to tackle the IoT challenges? So basically, there are three perspectives. That is a theoretical perspective, rigorous models that capture the system behavior at a different level of abstractions. At the same time, the engineering perspective is needed to tackle these challenges, in particular as the scale of IoT system grow and device diversify. In particular, architecture and networking technologies will likely continue to be evolved. And thirdly, the most system get deployed, it is important to recognize how human interact with the IoT technologies and what are the socio-technical barriers to adopt. And it is only based on this experience that the full societal impact of IoT can be realized. So now, another that is the opportunity gap. Undoubtedly, a gap exists between the current trends and the opportunity present by the IoT. Today, we have a lot of the smart devices around us, but most of them do not speak to each other. These situations referred to as a silios of the things. There is another terms. Individually, individual devices are quite smart on their own, but they still require come at the some levels of the human interventions or dedicated bridge that perform translation between the different protocols with which each technologies operate. From them to work together. So how we can minimize the human intervention, how minimize the human intervention, and how improve device to device interactions, device to device talk, so that device itself they can take a call and perform the operation. So here growth in predicted in the number of smart devices being used. The number of IoT devices having already surpassed the human population, according to the various researchers. And by 2030, the total number of connected devices may reach 125 billion to 1 trillion. So as I told that there is no fix. Every researcher have predicted their own. So the opportunity gap is the difference between these predicted numbers for the IT growth and the current trend for CILIO of the things growth. And this gap has already begun to close as various technologies are being developed to enable device to talk to each other and exchange data. So I'm just concluding only 2 or 3 slides. This is something is very important because when we talk about the IoT, sensor play a very smart role. That the sensor are one of the fundamental building blocks of the modern data acquisition system in IoT. So I think that I'm just here. I have just made in human. We have to see the things, and after seeing the things, there are a lot of the activities is going on. So after, the eyes act as a sensor. We see and then take some decision, take some data and take some decision and then move. Same things smell by the nose. We have to listen something through ears. Then we have to take the taste and then you have to act your movement of hand. Someone say that good morning only by the gesture or calling by the gesture. So all these are the human sensor. Human body also act as a sensor. But how these nature creature converted into the devices, and these devices definitely take the data from the environment and send to the cloud and then application and then process and then take the action, just like the human. So when we talk about the IoT sensor, so a sensor is a device that detect, measure, or indicate any specific physical quantity such as light, heat, motion, moisture, pressure, or similar entities by converting them to any other form which most electrical pulse. And there are over different hundred different type of sensor, but I think that it is already here. So we have a chemical sensor, flow sensor, I think humidity sensor, temperature sensor, force pressure sensor, leakage sensor, electrical sensor, magnetic, RFID, ultrasound. So everywhere, and because these sensors get the data from the surroundings and send to this thing. And now because I'm just going to conclude. So top 10 sensor is mostly used. That is a temperature sensor in household items, humidity sensor, also household pressure sensor in automobiles, proximity sensor, that is a position label sensor. Again, in home, just a very simple example: water level, accelerometer, gyroscope, and gas sensor, infrared sensor, and optical sensor. These are the very widely used sensor, and the basic component of a sensor, basically a processing unit, a battery, a transceiver, a memory, and then the communication, which communicate the gathered data. But there is that is a MyThing Smart sensor is a self-contained battery-operated multiprocessor IoT sensor that allow to capture critical data points like accelerations, temperature, humidity, pressures, and GPS. So rather than using the individual sensor, why not we have to make a one sensor that is known as a MyThing sensor, which have the capability of 5 sensors. So this smart sensor is integrated with the MyThing library. That is a hardware independent, small footprint and power optimized library of code. This is a very second last very interesting slide. That is a Internet of Everything is bringing together people, process, data, and things to make network connections more relevant and valuable than before, turning information into the action that create capabilities, richer experience, and unpredictable economic opportunity for the business, individual, and countries. That is put it by the Cisco. So here I'm talking about the Internet of Everything. That is a pillar of So there are 4 pillars: people, data, and process. And people connecting people, data converting data into the intelligence to make better decision, process delivering the right information to the right person or the machine at the right time, and the things physical or devices or the object connected to the internet from where you are getting the data. Now, very interesting slides. That is a solely sensor which is developed by the Google, and I can say that it could be a solely sensor. It could be a game changer in future. A number of product, wearable device, IoT devices, phones, and cars. And solar sensor is being developed as a part of project of Google Advanced Technology and the project groups, and is a low power radar design to use less energy and detect hand gesture on a sub-millimeter level, on a very sub-millimeter level, and it operates in a 60 gigahertz ISM band using the electromagnetic waves. The sensor detects a series of motions that are part of solely virtual tool gesture or virtual slider, virtual button, and other things. The project solely founder Egon Coffey said about the goal of the project. The hand is a very ultimate input device. How could we take this incredible capabilities and the fineness of the human action and the fineness of using our hand, but apply it to the virtual world? That is something very important. So our hand movement is give a give it in incredible actions. So how we capture these action convert into the data and put into the hardware, and the hardware take the decision as our hand. So now a very small video. Muskan, just please help me. Just this is my last slides. Here I'm have okay. Just a second. So the voice is audible. Muskan, the voice is audible.
Yes, sir.
Yeah. Extremely very amazing sensor, and definitely that would be change the whole scenario. And one thing I'm just understand the power of sensor. Now in mobile, I think that a small child who cannot speak, who cannot walk, but he or she is very is able to connect or play the game. So I think that in every home, a small child, they are well versed to interact with the phone. So this is the beauty of technology. This is the beauty of sensor. This is the beauty of sensing the activities of the human gesture. So now the future trends and learning path in IoT, the Internet of Things is a very emerging topics of technical, social, and economical significance. Consumer product, durable goods, and the car and trucks, industrial and utilities component, sensors and other everyday objects that are being combined with the internet connectivity and powerful data analytics capabilities that promises to transfer the way we work, live, and play. The projection for the impact of IoT to the internet and economics are impressive, as I discussed and as I told in my previous slides, with the some anticipations as many as 100 billion connected IoT devices and global economic impact more than 1 trillion by 2025. So it is a prediction that up to the 2025 we have 100 billion IoT devices, and the global economic from these IoT devices, that is $1 trillion. So at the same time, however, at the same time, Internet of Things faces significant challenges that could be stand in the same way of realizing its potential benefit. News headlines about the hacking of internet connected devices, surveillance concern, and the privacy fear already have captured public attention. So technical challenges remain, and the new always be there, and new policies and legal and development challenges always be very emerging. So with this presentations, my submission is that the Internet of Things engage a broad set of ideas that are complex but definitely solvable with the novel ideas and innovation. So with these words, I'm just stopping my presentation, and thank you all. Thank you so much. And if anyone have any questions, so please.
Thank you so much, sir, for an informative PPT. And we were able to learn a lot of things from it. And I will just open the chat box once if anyone has a query so they can sort it out.
And one more thing that we also have a session from 4 to 4:30 where we can discuss discuss the queries of each and every sessions. So any. So I think that Muskan, we can stop. Thank you. Any questions, or we should move ahead because after 10 minutes we have another session. Muskan, I think that yes.
Yes, I think it's done.
Yeah. So thank you so much, all the participants, and the next session will be start at 12:05. So I request all the participants that they will join this same link for the second session. Thank you so much.
लॉजिटेक का ठीक है कौन सा ऑन हुआ था प्रेजेंटेशन कर ली बंद करो तो पूछ लिया उससे। हाँ जी सुनील जी, हेलो।
Yes, sir.
स्लाइड्स आर विजिबल?
हाँ सर, स्लाइड दिख रही है सर, स्लाइड दिख रही है सर।
दिख रही है, बस ठीक है।
जी 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 सर, मेरी आवाज आ रही है आपको सर?
हाँ जी, आ रही है, बिल्कुल आ रही है।
आ रही है सर। तो सर बस 12:05 पे स्टार्ट करते हैं सर, 12:05 पे सर।
हाँ ठीक है।
थैंक यू सर, थैंक यू सर। एनी अदर रिक्वायरमेंट सर कोई?
बस और कुछ नहीं है, नथिंग।
ग्रेट ग्रेट सर, ग्रेट सर। सर बस विदिन 5 to 12:05 पे सर स्टार्ट कर देते हैं सर।
Mic on. Sorry.
Our second session is scheduled on artificial intelligence, its opportunities, trends, and challenges. Speaker is Dr. R.K. Singla, Professor, Computer Science and Applications, Punjab University, Chandigarh. Welcome, sir.
Should I start, ma'am?
Yes, sir. Yes, sir. Please, sir.
Okay, okay.
Yes,
Participants have joined?
Yes, sir. Participants are joined, sir.
Okay. My slides are visible? Voice is okay?
Yes, sir. Perfectly right, sir. Everything is perfect, sir.
Okay. So, I'm thankful to Dr. Sunil K. Singh, HOD, Computer Science and Engineering and coordinator of FDP also, and Dr. Manpreet Singh, principal of the college. And dear participants, I'm thankful to all of you for inviting me to today's session. My talk will be general on artificial intelligence, opportunity, trends and challenges. Just wait. Okay, so the agenda of my talk is understanding about AI, its history, what is AI automation, what are the advantages and disadvantages, certain applications in domain areas. Then I'll talk about AI versus machine learning versus deep learning. Then I'll give you two demos. One is web-based, which is Google's Teachable Machine, and other is a desktop application by Microsoft, lob.ai. So we'll be exploring machine learning live in the browser as well as a desktop application. In the end, I'll talk about AI growth and future of humanity. Then I have framed certain questions. So we'll be talking about those questions. For example, questions such as, when will AI exceed human performance? How can AI transform developing countries? How are developing economies adapting to the change due to the rise of AI, and so on. Will AI replace teachers completely? How long will it take until machines greatly supersede human level intelligence? So we'll have some questions already framed for you, and we'll go through the responses to these questions. So AI, it has captured the imagination in a way not seen since the development of internet nearly 3 decades ago. All of us have seen OCR, handwriting recognition, face detection recognition, for example, Apple iPhoto, visual search, vehicle safety system. So we have seen AI encompassing anything from Apple's Siri to self-driving cars, to Google's search algorithms, to Google's voice search, to machine translation, to robots with human-like characteristics, to autonomous weapons, and many more such systems which we see all around us. If you are using technology today, a smartphone, a computer, or any connected electronic device, then you are bound to be using AI as part of the embedded software of that technology. Already these commonplace examples we see all around us: voice recognition, Siri, Alexa, Cortana, Netflix, Imagine's predictive analytics, navigation apps, Google Maps, video games, fraud detection, translation software. So all this we see all around us. Behind all of this technology is a complex set of algorithms, CPUs, GPUs, and computer servers with increasing level of sophistication that are designed to accelerate input and output of information, increasing the quality, complexity, and volume of transactions with our devices and enhance our quality of life. Thus, we are all already living in the world of AI. Over the past few years, AI has exploded, and especially since 2015. Much of all that has to do with the wide availability of GPUs, through which parallel processing is much more faster, cheaper, and more powerful. It has also to do with simultaneous one-two punch of practically infinite storage and a flood of data of every stripe, that whole big data movement. You talk about images, text, transactions, mapping data this way. So what comes next? Where are we headed with AI? And what level of responsibility do the designers and providers have with managing AI technology? Will we control AI technology or will it control us? I very much look forward to discuss all this in the slides to come. So based on these AI developments, we have some questions to start with. Are there tasks which cannot be easily be automated? If so, what are the limitations? How do computers' abilities compare to that of humans? A computer, for example, a computer can do some things better than a human can do. For example, adding 1,000 four-digit numbers, drawing complex 3D images, store and retrieve massive amount of data. So computer is good, it is better than us. However, there are things humans can do much better. What are those things? A computer would have difficulty identifying the cat or matching it to another picture of a cat as compared to a human. Within no time, human being can identify cat as a cat. But to the computer, lot of data has to be provided, lot of things have to be done. It is difficult for the computer. The algorithm is really very complex. So first thing first, we have to understand why we use the term intelligence in regard to humans and artificial intelligence in regard to computers. What defines intelligence? What is that? We assume humans are intelligent. Are monkeys intelligent? Are dogs intelligent? Well, these are the questions. So I'll go through the definition of artificial intelligence to start with. Intelligence is the capacity to learn and solve problems. AI is the simulation of human intelligence by machines. For example, developing a software to pick out objects in a picture, as I've given you the example of a recognition of a cat. There are some more definitions of AI in the literature. The ability to mimic or duplicate the functions of the human brain. It is the intelligence of machines and the branch of computer science which aims to create it. Branch of computer science that is concerned with the automation of intelligent behavior. AI are technologies that display intelligence as it perceives its environment and takes action to achieve a goal. Okay? So broadly, AI has two major purposes. One is to create expert system. Number two is implement human intelligence in machines. So we talk about these two major purposes of AI. What is involved in intelligence? Ability to interact with the real world, to perceive, understand, and act. For example, speech recognition, image understanding, ability to take action that have an effect. Number two is reasoning and planning, modeling the external world, given input, solving new problems, planning and making decisions, ability to deal with unexpected problems, uncertainties, learning and adaptation. We are continuously learning and adapting. Our internal models are always being updated. For example, a baby learning to categorize and recognize animals. Okay? So the special ability of AI is to reach a solution based on facts rather than on a preset series of steps. This is what closely resembles the thinking function of the human brain. Some academic disciplines relevant to AI. So these are some of the disciplines mentioned over here, and they have their role in AI. For example, philosophy, mathematics, probability, statistics, economics, neuroscience, psychology, cognitive science, computer engineering, control theory, linguistic, laws, and some others. Each of these disciplines, they have some role to play. For example, computer engineering, building fast computers. Mathematics, formal representation and proof. Algorithms, computation, decidability, undecidability, tractability, intractability, and we talk about all those things. Psychology, cognitive science, for example, how do people behave, perceive, process cognitive information and represent knowledge. Okay, so these are some of the disciplines relevant to AI. Next, AI versus human intelligence. How do we compare? The pros are human intelligence, intuition, common sense, judgment, creativity, beliefs. The ability to demonstrate their intelligence by communicating effectively, reasoning and critical thinking. So these are the pros of human intelligence. About AI, ability to simulate human behavior and cognitive processes, capture and preserves human expertise, very fast response, ability to comprehend large amounts of data. What are the cons? Human intelligence. Humans are fallible. They have limited knowledge bases. Information processing of serial nature proceed very slowly in the brain as compared to compared to computers. Humans are unable to retain large amount of data in the memory. AI. Cons, no common sense. Cannot readily deal with mixed knowledge. May have high developmental costs. It also raises legal and ethical concerns. Some brief history of AI. In 1950, English mathematician Alan Turing wrote a landmark paper titled Computing Machinery and Intelligence that asked the question, can machines think? Further work came out of a 1956 workshop at Dartmouth sponsored by John McCarthy. In the proposal, he coined the phrase, a study of AI. So Turing asked, can machines think? He felt that such machines would eventually be constructed. But he also realized a very bigger problem. How would we know that if we have succeeded? This is the timeline, the history of AI. If you can see this slide starting from 50, okay, this term was coined. Then you have some 59, 69, 80, okay, 77, Google search to search iPhone application, Google search to search. Then you have Google if it is readable, Google Brain developed, Apple introduced intelligent personal assistant, okay, intelligent personal digital assistant, PDA. Then it came something related to supercomputer speed. Okay, so then you have lobe.ai, fast.ai, okay, in 1718. Okay, so this is 19 onwards, it is continuing. It is self-driving cars. Okay, so I have mentioned all these things. Then some game like AlphaGo, okay, beating the computer, beating the man, the human being. Okay, so this is the timeline. It's generally available. I have tried to put it in a single slide. These characters are very small, not readable to me also. Okay. Categorization of AI. Three things: narrow intelligence, general intelligence, super intelligence. This is how we categorize AI. Narrow means one specific task. General means many things like a human. Super intelligence more than what a human can do. So that is the difference between narrow intelligence, general intelligence, super intelligence. Okay, so the definitions are given over here. Okay, it is better, so only this. One specific, many things like a human, more than what a human can do. Examples of AI technology. So as shown in the diagram, automation, machine learning, machine vision, NLP, natural language processing. It is not NPL, NLP. Robotics, self-driving cars. In machine learning, we talk about deep learning, supervised learning, unsupervised. Okay. In natural language processing, we talk about content extraction, classification, machine translation, question answering, text generation. Then you have the concept of expert systems. Then in vision, you have image recognition, machine vision. In speech, you have speech to text, text to speech, and so on. Difference between AI and automation. AI is designed to simulate human thinking, ability of machine to perform cognitive functions we associate with our mind. Automation is software that follows pre-programmed rules. Use of electronics and computer-controlled devices to assume the control of processes, for example. What are they saying? Okay. AI to create technologies that ably mimic what a human can do, think. Automation has a single purpose to let machines perform repetitive tasks. AI designed to constantly seek patterns, learn from experience, self-select the appropriate responses in situation based on that. And automation is designed to free up time for humans to focus on more important tasks. AI, it is about creating a system that is more powerful than you could possibly imagine. In automation, the end result is a more efficient and a more productive workforce. But the big issue is accelerating progress in AI and automation is creating opportunities for businesses, the economy, and society. How AI and automation will affect the work? This is the question. Key workforce transitions and challenges. This is the issue. But why AI is important? AI automates repetitive learning and discovery through data. It adds intelligence. It adapts through progressive learning algorithms. It analyzes more and deeper data. It achieves incredible accuracy. It gets the most out of the data. Threats of AI and automation. Replacement of entire workforce. Widen economic divide in society. AI is lowering the cost of attacks. Political manipulation and propaganda. Spell the end of human race. These are some of the real threats. Next, I'll talk about certain applications of AI. To start with, in classrooms. Applications of AI-based education technology, it includes the following. Tutoring, AI-based. Personalized learning. Testing. Automating the tasks related to education in the classroom. Attendance, grading assignments, generating test questions and all that. So these are the major applications of AI in education. AI is paving the way for personalized adaptive learning. So these are, all these slides I'll share with the participants. I'll be handing it over to Professor Sunil Singh. Okay, so already some part of it is available on my website also. So it is paving the way for personalized adaptive learning. These are some of the examples on the right. Later on, you can go to these websites and just see to it. AI is enabling advising systems that enhance the student experience. Yes, from students' point of view. AI is being used for student assessment also. Okay, already I've told you some links are given. AI plays a major role in the creation of smart content. Okay? For example, the scenario of me giving a voice command as prepare a presentation on role of AI in teaching and learning for me tomorrow is very likely in the near future, where AI will help me prepare material with relevant content. It will adapt to my way of giving seminars and data I have previously used. The result is a very feature-rich source for learning. Okay, so that is the role of AI in creation of smart content. Role of AI in the creation of immersive classroom technology. For example, offering exciting new opportunities in the form of immersion that relies on new wearable devices like the Microsoft HoloLens or augmented reality now being integrated into smart devices. Okay, being able to see and interact with the human body or a microscopic cell instead of just reading about it in a book, with the supplement of an AI providing tangible, individualized learning support. It will transform how students engage with the material. It is already in place with a very entry-level technology, but in future, digital classrooms equipped with cutting-edge technology, AI products will be integral in the new digital and AI era very soon. AI can enhance the experience of students with disabilities. So that also is there. Okay, some features and the role of AI to tackle to that problem of hearing and all that. Okay, deaf and hearing. It is advancing the capabilities of learning analytics. Okay, it involves what is learning analytics, LA? It involves measurement, collection, analysis and reporting of data about learners and the context in which learning takes place with the aim of improving the teaching and learning environment. AI is transforming other aspects of academic life also. Okay, it is making inroads into many other aspects. For example, transforming libraries, communication with students, academic research, textbook creation, external outreach. Okay, so it is handling other aspects of our life also. AI also it raises ethical, moral, and privacy concerns. Because AI system, we know, it requires large amounts of data, including confidential student and faculty personal information, depending upon the application. Therefore, its uses raises a myriad of ethical, moral, and privacy concerns which must be addressed. Okay. AI is challenging to be implemented in higher education. Okay. Because of this ethical, moral, and privacy concerns, okay, various institutions attempting to implement and scale up AI system face numerous other challenges. Who will be responsible for developing and monitoring AI policies and practices, for example? Okay. This is the very first question. What are the legal complications for faulty student diagnosis, okay, if it is AI based? Okay. Where is AI in teaching and learning today? Last year, Ashok Goyal at Georgia Tech used an AI program called JIL as a teaching assistant, fittingly in his AI class only. The program replied to student email queries regarding assignments based on IBM's Watson AI platform, trained on 40,000 postings on a discussion forum to reply to similar questions based on prior responses. JIL has a confidence level of 97%. Most students were surprised when told that JIL was a computer program, answering their queries. Next year, it is expected that JIL should be able to answer 40% of all students' questions. Smart content, already I told you. As of today, intelligent tutoring system, virtual facilitators and learning environments, virtual or artificial reality tools, intelligent mining and use of student data for things like predicting performance, improving performance of students, customizing admissions, learning pathways, learning modes. But some of these are in their infancy, probably. Okay, so this is about education. Applications of AI in medicine. A medicine clinic can use AI system to organize bed schedules, make a staff rotation, provide medical information. Applications in the field of cardiology, neurology, embryology, sonography, complex operations of internal organs, okay, image-guided surgery, image analysis, image enhancement. These are some of the applications being used in medicine. In music, scientists are trying to make the computer emulate the activities of skillful musicians. For example, smart music, composition, performance, music theory, sound processing. These are taken up by this smart music tool based on AI. In telecommunication, many telecommunication companies make use of heuristic search in the management of their workforce. For example, British Telecommunication Group has deployed heuristic search in a scheduling application that provides the work schedule of more than 20,000 engineers. Robotics and AI. A robot is a mechanical or virtual artificial agent, usually an electromechanical machine that is guided by a computer program or electronic circuitry. Robots can be autonomous or semi-autonomous. It may convey a sense of intelligence or thoughts of its own. Humanoid robot and AI. Sophia is a social humanoid robot developed by Hong Kong-based company Hanson Robotics. Sophia was activated on April 19, 2015. She made her first public appearance in a festival in mid-March 2016 in the United States. In 2017, Sophia became a Saudi Arabian citizen, the first robot to receive citizenship in any country. In gaming, in the early days, gaming technology was not broadened. Physicist Billy created the first video game in 1958. It was called Tennis for Toe. But now, AI technology has become vast and standard has also been increased. We talk about Sudoku, Fear, Fallout, and many other names. In banking, organizing operations, invest in stocks, manage properties. Robots beat humans in a simulated financial trading competition. Some other applications include loan investigation, ATM design, safe and fast banking. There are many other applications. So these are some of I have mentioned. So everywhere, in every domain, there is an application of AI. The credit granting, information management and retrieval, AI and expert system embedded in products, plant layout, help desk assistance, employee performance evaluation, shipping, marketing, warehouse optimization, satellite controls, network developments, nuclear management, and so on. Next, a brief about the theme of your FDP. Okay, it is on AI plus IoT. So AI and IoT blended. Already in the first session, Professor Sunil K. Singh has discussed all about it. I have 2-3 slides on this. Today's business world is changing with the adoption of IoT. IoT is helping and prominently capturing a tremendous amount of data from multiple sources. However, wrapping around the multitude of data coming from countless of IoT devices makes it complex to collect, process, and analyze the data. IoT is that we collect the data, but it is difficult, very complex to collect also, process also, to analyze also. The convergence of AI and IoT, we say convergence of AI and IoT as artificial intelligence of things. That also is the nomenclature these days. The convergence can redefine the way industries, businesses, and economies functions. AI-enabled IoT creates intelligent machines that simulate smart behavior and supports in decision-making with little or no human interference. While IoT deals with devices interacting using the internet, AI makes the devices learn from the data and experience. So AI and IoT are the top technologies companies are investing as of today, mostly, to increase efficiency and provide a competitive advantage. At its core, IoT is about sensors implanted into machines which offer streams of data through internet connectivity. All IoT related services inevitably follow 5 basic steps called create, communicate, aggregate, analyze, and act. Undeniably, the value of the act depends on the penultimate analysis. Hence, the precise value of IT is determined at its analysis step. This is where the AI technology portrays a crucial role. So I have shown AI and IoT functional view. It is create sensors, then communicate through networks, aggregate, then you analyze, then you act on it. So while IoT provides data, AI acquires the power to unlock responses, offers both creativity and context to drive smart actions. As the data delivered from the sensor can be analyzed with AI, businesses can make more informed decisions. So AI, artificial intelligence, IoT succeeds in achieving the following agile solutions: manage, analyze, and obtain meaningful insights from data, ensure fast and accurate analysis, balance requirements for localized and centralized intelligence, balance personalization with confidentiality and data privacy, maintain security against cyber attack. Some of the benefits of AI-enabled IoT: boosting operational efficiency. I have given an example of this. For example, Google brings the power of AI into IoT to reduce its data center cooling costs. This is one example. Second is better risk management and automating for the prompt response. Fujitsu, for example, ensures worker safety by engaging AI for analyzing data sourced from connected wearable devices. Third benefit, triggering new and enhanced products and services. Natural language processing is getting better at allowing people to communicate with devices. Undeniably, IoT and AI together can directly create new products or enhance existing products and services by enabling the business to rapidly process and analyze the data. For example, Rolls-Royce plans to leverage AI technologies in the implementation of IoT-enabled airplane engine maintenance amenities. Indeed, this approach will support to spot patterns and discover operational insights. Next, benefit is eliminating costly unplanned downtime. For example, Deloitte find the following results with AI and IoT. 20% to 50% reduction in their time invested in maintenance planning. 10 to 20% increase in equipment availability and uptime. 5 to 10% reduction in maintenance costs. So, overall, IoT coupled with AI technologies can lead the way to the advanced level of solutions and experience. To obtain better value from your network and transform your business, you should integrate AI with incoming data from the IoT devices. So this is brief about the theme of your FDP. Now, next part is, before I demonstrate two tools, let's briefly go through the differences among AI, machine learning, and deep learning. The easiest way to think of the relationship is to visualize them as concentric circles as shown. With AI, the idea that came first, the largest. Then came machine learning, which blossomed later. And finally, deep learning, which is driving today's AI explosion, fitting inside both. Okay, so deep learning, machine learning, AI. AI is the bigger one. Smaller than that is machine learning. Part of that, subset of that is deep learning. AI, it is a human intelligence exhibited by machines. It is a broad field of study dedicated to complex problem solving. What is machine learning? An approach to achieve AI. It is usually considered as a subfield of AI. ML is a data-driven approach focused on creating algorithms that have the ability to learn from the data without being explicitly programmed. For example, machine learning helps keep your inbox relatively free of spam. So that is the example of machine learning. Deep learning, it is a technique for implementing machine learning. It is a subfield of ML focused on deep neural networks able to automatically learn hierarchical representations. For example, picking images of cats out of YouTube videos was one of the first breakthrough demonstrations of deep learning. So this is the difference among AI, machine learning, and deep learning. Now, what is machine learning? Learning is any process by which system improves performance from experience. Okay? According to me, the definition of machine learning is algorithms generate algorithms. It is an important concept to understand because in machine learning, learning algorithms, not computer programmers. Okay? Learning algorithms, they create the rules and not the computer programmers. Okay? So according to Tom Michel, ML is the study of algorithms that improve their performance P at some task T with experience C. So well-defined learning task according to Tom Michel is triplet P, T, E, performance, task, and experience. So by means of this slide, difference between traditional programming and machine learning. In traditional programming, you have a computer, you give data and the set of instructions called program, and you get the output. It follows a series of steps to reach a conclusion. What is machine learning? You have a computer, you give it data and output also, and it generates the algorithm, the program. It uses the technique of search and pattern matching. Programmer design AI software to give computer only the problem, not the steps necessary to solve it. Okay? Only the problem is given to us. Data is given and some output about data is given, for example, and then you get the algorithm out of it. So that is machine learning. This is a brief history of machine learning. Okay? In 1990s, we call it as 90 to 2000, first generation, the back end. Second generation, the human side. 2000 to 2010. Third generation modern machine learning 2010 to 2020. Maybe it is continuing third generation or fourth generation, you can say, after 2021. In the first generation, we talked about large data sets, okay, related to fraud detection, search algorithms, supply chain management. In the second generation, data about humans, the human side, recommender systems, social media, commerce, advertisements, okay, about the human side. Third generation, modern machine learning. It is related to pattern recognition, speech recognition, computer vision, translation. So this is how we have the history of machine learning into three generations, and now fourth is going on, where it is a continuation of this speech, computer vision, translation, and many more things. This is brief about neural networks and deep neural networks defined. Neural network, also called ANN, it is a machine learning based algorithm that mimics the pattern of the human brain and processes and learns from data for solving complex problems. Okay, as shown in this diagram, okay, you have the input layer, then you have the hidden layer, okay, where all processing goes on, and then you get the output layer as shown over here. This is an example of an image. Okay, what you do in deep learning or neural network is you chop your image into bunch of tiles that and put it into a first layer of the neural network. Okay. So the first layer passes the data to the second layer. The second layer of neuron does its task, and so on until the final layer and the final output is produced. Okay. So later on you can go through over here. I have taken the example of a stop sign on the road. Okay. So how do we get the colors and all that? So I'll not go into the details. Languages used in AI: Python, R, Lisp, Prolog. We know all this, so I'll not go into it. When do we use machine learning? We use machine learning when human expertise does not exist. For example, navigating on Mars. Humans cannot explain their expertise, speech recognition. Models must be customized, personalized medicine. Models are based on huge amounts of data, genomics. Clear, learning isn't always useful. For example, there is no need to learn to calculate payroll because payroll computing is based on fixed set of instruction steps. A classic example of a task that requires machine learning. It is very hard to say what makes it out of all this. So for this, we have to learn from the data. We have to make the machine learn from the large set of data. Some more examples of tasks that are best solved by using a learning algorithm. Recognizing patterns, okay, facial identities, facial expression, handwritten words, spoken words, medical images, generating patterns, recognizing anomalies, for example, computer network anomalies, prediction, stock prices, currency exchange rates, and so on. Sample application, web search, computational biology, finance, e-commerce, space exploration, robotics, information extraction, social networks, debugging software, and many other applications of your, say, favorite area. Defining the learning tasks. Improve on task T with respect to performance metric P based on experience A. Okay, so these are some of the examples given over here. For example, for the handwritten words, the task is to recognize handwritten words. P is the percentage of words correctly classified, performance. E is the database of human labeled images of handwritten words. So that way you define your learning tasks. Types of learning. Supervised learning, unsupervised learning, semi-supervised, and reinforcement learning. Supervised, you give the training data and the desired output with labels. Okay. Then unsupervised learning, you give the data without desired outputs. Semi-supervised, training data plus few desired outputs, mix up of supervised and unsupervised. Reinforcement learning, rewards from sequence of actions. On the right hand side, I have given the example model A, unsupervised learning. Model B is supervised learning. You have a label given to the object. It is a daisy, it is a tulip. Otherwise, you are given the data in model A, but no labeling is done. So that is unsupervised learning. So supervised learning is given your data x1, y1, x2, y2, xn, yn, learn a function fx to predict y given x. Okay? Y is real valued means regression. Okay? So you are given x1, y1, x2, y2, x and yn. Given x, I want to predict y. Okay? That is supervised. Then this is regression. What is classification? Given again x1, y1, x2, y2, xn, yn. Learn a function fx to predict y given x. It is categorical. Categorical classification, discrete. Okay? Categorical means discrete. For example, breast cancer, malignant or benign. One of the two. But in supervised learning, X can be multidimensional also. Each dimension corresponds to an attribute. Unsupervised learning, shown by means of the diagram, given the data x's without labels, output hidden structure behind the axis. For example, use clustering. Okay? This data is given to me. Over here, I say this is the cluster, one cluster, the second cluster, then third cluster. This is how I can understand the unsupervised learning. Only the axes are given and this example. Reinforcement learning is given a sequence of states and actions with the delayed rewards output a policy. Policy is mapping from states to action that tell us what to do in a given state. For example, in game playing. It depends upon the state. What are the previous actions taken by your opponent or yourself? Next, designing a learning system. Choose the training experience. Choose exactly what is to be learned, that the target function. Choose how to represent the target function. Choose a learning algorithm to infer the target function from the experience. As shown in this diagram, you have from the experience or from the environment, you have some data. You have the training data for learning purposes. Okay? You acquire knowledge out of it. Once you acquire knowledge, you apply it, and then you apply on the data. You call it testing data, and you have the performance element based on that. So this is how we design a learning system. So machine learning in a nutshell. Tens of thousands of machine learning algorithms, hundreds new every year. Every ML algorithm has three components: representation, optimization, evaluation. Various function representation. Numerical functions, for example, linear regression, neural networks, sport vector machine. Then you have symbolic functions like decision trees, rules in proposition logic, rules in first order predicate logic, instance-based functions, nearest neighbor, case-based. Then you have probabilistic graphical models, naive-based, Bayesian networks, hidden Markov models, probabilistic context-free grammars, Markov networks, and so on. So these are some of the function representations. I have explained the purpose of SVC on the right hand side and the left hand side, the concept of a hyperplane. Various search optimization algorithms. These are some of the names: gradient descent, perceptron, backpropagation, dynamic programming, HMM learning, PCFG learning, already explained, divide and conquer, decision tree induction, rule learning, evolutionary computation, genetic algorithms, genetic programming, neuro evaluation. These are some of the search and optimization algorithms. Then how do we evaluate? These are some of the metrics: accuracy, precision recall, squared error, likelihood, posterior probability, cost, utility, margin, entropy, KL divergence. Some of these metrics we use depending upon the requirements. Lessons learned about learning. Learning can be viewed as using direct or indirect experience to approximate a choosing target function. Function approximation can be viewed as a search through a space of hypotheses, representation of function, for one that best fits a set of training data. different learning methods assume different hypothesis spaces, representation languages, and or employ different search techniques. So this is what we have learned about learning. ML in practice and its workflow. Understand domain, prior knowledge, and goals. Data integration, selection, cleaning, pre-processing, etc. Learn models, interpret results, consolidate and deploy discovered knowledge as shown in the diagram. Okay, you have a data. Okay, this is photo. Some data collection, cleaning, and pre-processing. Then it is labeling for supervised learning problems. Then you extract the features from your data. For example, for this picture, legs, tails, ears, some information about this object. Then you build a model, means you train based on your data. You make something out of your data. That's what your data represents. That is building a model. Yeah? You have a large amount of pictures, large set of pictures. So you extract some features out of it, and then you build a model. You train your model. Then you test it. You apply, you predict, and find out the performance. So this is ML in practice and its workflow. Labeling data. You have a bird and a cat. You label it as a bird and a cat. Then you have certain features of a bird. For example, 2 legs, feathers, a bark. Then you have cat. The features are 4 legs, tail, fur, whiskers. Okay, so that way you label your data. How does AI see images? Okay, AI works with digital data. Digital image data has pixels. We apply labels and features to the data to tell the AI what attributes an object has. But how does AI know what tail is? The algorithm will look for visual patterns across the images based on the features we describe. For example, with lots of images of cats, it will see patterns of features based on the shapes it sees. It will start to see cat having a certain shape for ears, as shown in the diagram. The AI algorithm sees the image using the pixels and looks for the differences in color gradients between the pixels. It uses the pixels to look for an outline. This is known as edge detection. Similarly, not only images, for sound and text also, the AI will also find shapes and patterns representing in the digital data. This is how AI sees images and your sound and your text. Demo. Before I go further about AI, so the first is Google Teachable Machine. Okay, so it offers image classification. Okay. Demo is about image classification by a teachable machine of Google and Microsoft's lob.ai. Then human body pose classification by a teachable machine. Okay, so teachable machine here from Google, which is web-based. Lob.ai is from Microsoft, which is a desktop application, AI application. So firstly, let me just go through the slides. So at the end, if we have time, I'll demonstrate also. Machine learning is increasingly prevalent in daily life, powering recommender systems, translation, speech transcription, and more. Yet, many people whose lives are affected by ML lack detailed understanding of how it works and have no access to creating their own models. One aspect of deepening digital inequality. With numerous instances of algorithmic bias and the widespread potential for the social impact of ML to spread to new arenas of everyday life, it is essential to enable people with diverse expertise and experiences to engage with ML. So that is the aim of Google Teachable Machine. So one approach to broadening engagement with machine learning is with the tools that enable users without technical knowledge to create their own machine learning models. So Teachable Machine is a web-based interface that allows people to train their own ML classification models without coding using their own webcams, images, or sounds. It uses transfer learning and machine learning technique to find patterns and trends within the images or sound samples and create a simple and easy classification model within seconds. With the transfer learning, a user is able to add their own data and retain a model on the top of the previously trained base model that has learned a specific domain from a large data set. Okay, so this is Google Teachable Machine. The version is 2.0. It was launched in 2017, okay, to make it accessible to wider public without coding, without any specialized training, knowledge in computer science or software coding. So this is the website, teachablemachine.withgoogle.com. This site is a move that reflects the current trend of the personalization of AI. It is AI personalization, shifting the algorithms from the cloud to the user space, be it their desktop, their phone, or other smart device. So that is not the biggest problem though. The real issue is that the model used for training the algorithm under the common supervised learning model require massive data sets and excessive amounts of CPU power. Okay, so at the back end, on the cloud, Google has the excessive amount of CPU power for me, okay, to explore machine learning on my desktop, okay, in the browser itself. Okay. On the back end, Google is also maintaining massive amount of data sets, okay, so that whatever object I take of my own for a machine learning problem, so according to that, a lot of data is already available on the cloud. So as the situation currently stands, the bulk processing is done on the cloud by Platform as a Service, PaaS, while offer machine learning as plug and play APIs which encapsulate the necessary pre-trained algorithms. So this is Google's Teachable Machine 2.0. So with this, we can create this with this web-based tool. We can create simple and effective algorithms in the browser that can identify pattern on images, identify patterns on audio, identify poses or gestures. Okay? Poses means left hand up, right hand up, that way. Okay? It finds that. So it can recognize images, sounds, and poses, three things. Okay? You can do it through your files, already existing files, image files or sound file or some other files, or you can use live mic, or you can have web camera. Okay? You can click the photos also. So that is available with the tool. Google also says that this new version 2.0 was built using its in-house open source TensorFlow machine learning framework as before. It's technically TensorFlow.js, which enables models developed in JavaScript to run directly in browsers or in the JavaScript runtime environment Node.js. That confers the benefit of interoperability. Models and examples can be saved to Google Drive and from there shared with other users or the community. Okay. I'll go to the next slide. So in this demo, what I'll be showing you is already I have built a machine learning model where I have photograph of myself and myself with a cell phone. So whenever I have a cell phone in my hand, it will say me with cell phone. If I do not have a cell phone, it will say it is a photograph of me only. Okay, so that is already I'll show you. So this is how we go about it, how teachable machine works. Gather data, train the model, preview and export the model. Okay, 3 steps we have to follow. Gather your data by selecting classes. For example, I have told you 2 classes. Only my photograph, only photograph of me, or me with my mobile in the photo. So that is 2 classes. You can have multiple classes also. Then you train your model based on that data of 2 classes. Then you preview it, means you test it. And then you can export it, your model, to your projects. Okay? For example, you can generate a link, website link, and you can put it into your projects. And that is a link on the Google Cloud. It is saved over there forever. Okay? You can download your model and you can host it online for free. Okay? So it is from Google. So these are the 3 steps we will follow in Google Teachable Machine. So this is the user interface. When you start, okay, this was the website. Okay, it was given over here. This is the name of the site, Teachable Machine with google.com. When you do this, this is the first screen you get. This one. Okay, this is for the help. So it says gather, train, and export. We have class 1, class 2. Then second step is train the model. So the class 1 means you put the pictures over here. Class 2, you put the pictures over here, either from the file or from the web camera dynamically, there and then. Then you train the model, then you test the model, or you export the model. Test also and export also. Just see, this train a model by showing it a bunch of pictures of oranges. This is teaching a model starts with showing it a lot of examples of oranges. So it can recognize patterns. So to the camera, you can show your object. You can click your photo, you can show the object, okay, in your hand. Okay, so it goes on recording it. Okay, it goes to the neural network and it captures the various features of that particular object. After you have done this, the input is done. Then next is you show it another image, another product, another object. So what do you think this is? So your model, you have trained the model to say it 37% confident that it is an orange. Okay, it is an orange. So learning from the lot of examples, then it can evaluate the new data. Okay, it evaluates a picture of kiwi based on the orange photos. Then it says it is only 30% confident. So this is how the tools work. These are the steps of them. Visit this site, click on Get Started. You will get the new project. Click on New Project. Then it will show you this interface. It says 3 applications: Image Project, Audio Project, Pose Project. So you can select any of these 3. So for example, to start with, you can select Image Project. The next screen, once you say Image Project, then it says class 1, class 2. You can have multiple classes also. Okay, 3, 4 classes also. So here class 1 means you give the name to the object. Okay, so the first object is me, my photograph. Second, class 2 will be, if I click on class 2, I change it to me plus my phone. Okay, if I click on webcam, then web camera will be on and I can click my photographs of the object I have mentioned as class 1. Okay, once the data is ready, then you train the model, then you preview it. Okay, for example, over here, rename class 1 and class 2 to me and me with my some object, for example, me with my phone. Okay, so this is the interface. Here you can add more classes, add a class 1, class 2, class 3. You can have multiple objects also for classification. So this is how you gather your data. Turn on your webcam, you just click on webcam. Okay, for each class and click hold to record. Once you click on webcam, then it will be hold to record. Okay, mouse click, left click and hold it. And your photo, you move your say face here and there and record different pictures so that it recognizes you as me. Whenever you come before the camera, it will say me. Okay, so that way you click the photographs. Similarly, me with my phone. Now I have phone in my hand as shown over here. Okay, front side, back side and all that. So this is, you record your data. The simplest is only 2 classes I have taken. I can take many more classes. Okay, I can have, rather than a phone in my hand, I can have the mouse in my hand. I can have the car keys in my hand. All these classifying objects. So you record the data by clicking on webcam, and then you have all of this data. It will say so many images. It will say so many images, as many as you can capture. Over here, it is showing only 6 and 9, which is very small. Next is you train your model. Click on train. So it starts training your model based on your data. It is not only 5 and 9. Say 5 images of me, 9 images of me plus mobile in my hand. It is not only 14 total images. At the back end on the cloud with Google, by say transfer learning, they have large collection of data, objects, pictures. So it is not based on only 14. So the time it takes to train the model will vary depending on how many images samples you gave it. But it usually takes somewhat around 30 to 40 seconds. Then after training, you preview your model. Over here, nothing you have to do. You have to only press train. Based on your data, it will train the model so that you can test it later on. Previewing your model. Once your model is trained, a preview should appear. Try it out. If it is shaky in some angles or positions, go back and record more samples with those angles or positions. Agar output theek nahi aa rahi, the purpose is that you do it again and click more photographs. Click more photographs. As the data will increase, obviously the performance will also increase. Keep retraining your model after any new data is entered. Okay. So over here it is shown. Okay, when I click on preview, this is my photograph. It says output is either me or me plus phone. It says me 100%. If I will bring the phone in my hand, it will go to me plus phone. Or sometimes it says it toggles between me and me phone. If there is some confusion, then you can add some more data. Okay? You can go to that particular class and click more pictures. Okay? So that next time you show that object in your hand, it is able to recognize me plus phone as me plus object as 100%, as shown in this diagram. Exporting your model. So the tool is available for without any knowledge of computer science, but it should be useful to computer scientists also. So what they have is you can export your model. Teachable machine will host your model on Google servers, so you can use it in any project you want to. To upload your model to teachable machine servers, cloud servers, click on export model. Okay? Click on this export model and then click upload my model. Once the window pops up, after a few seconds, you should see a link to your model available under your shareable link like this over here. Your shareable link, you just copy it from here. You copy it from here, you put it in the browser, any browser, okay, as a URL, or to put it any of your project. You click on this, your same application will run. Machine learning application will run. Okay, so this is how you export the model. You can also, from here, you have TensorFlow.js, you have TensorFlow, you have TensorFlow Lite. From here, whatever is the code generated by this application, computer scientists can make use of that code also for further editing. Yeah, for further editing. For example, you can take it to REPL, you can take it to some other web editors which are online available. Okay? So you can make use of all those and use this code over there. They are, I think it is REPL, ML5JS, P5.js. These are some of the web editors which are available as of today. So this code can be taken out there. It can be taken out there. You can download also from here, export your model, okay, JSON and all that. Files will come. You have to go through all those. So this is about teachable machine from Google. So it is shown over here, sorry. Next slide. Making your website based on teachable machine. It is time to add your teachable machine model to your own project. Scroll down and copy the code teachable machine generator for you. Spin up a new HTML REPL at this REPL.it at languages HTML. Paste the code in between body tags. Okay, so you have your code pasted over there. Before you run, make sure to read through the code you just pasted. It is fully commented and super easy to understand. It is important to understand what exactly you are doing. Otherwise, you have not learned anything. Run the REPL and then open your website in a new tab by clicking the icon at the top right. Once you click start and give the site access to your webcom, you should see your model again. As over here, I have shown you myself with my phone. It is saying me plus phone is 1.00, 100%. Yeah, me is 0, so phone is there, so it recognizes the phone in hand. So this is the example. Before I demonstrate, let me go through lob.ai from Microsoft. It is a desktop application. You have to download the installable file from Microsoft website. So that is why it is a desktop app. So again, AI and machine learning are complex. We must admit it, and they require advanced knowledge and experience. But recently, Microsoft also started to change this scenario with a very user-friendly tool called Lob, a free software framework that allows anyone to create machine learning models, no technical skills needed. Lob app designed for Windows and Mac only supports for the time being image classification. However, the tech giant Microsoft is planning to expand the app to include other models and data types in the future. According to Lob website, the app needs to be shown examples of what the users want to learn, and the app automatically trains a custom machine learning model that can be shipped in the user's app. The app, Lob, leverages open source machine learning architectures and transfer learning to train custom machine learning models on the user's own machine. User can just initiate the process by importing training images of the things they want Lob to recognize. Microsoft further explained that once training is done, the models can easily be exported to run on industry standard platforms and work on apps, website, or devices. So, lob.ai, the website. This I have told you already, so I'll not go into this. These are just some Lob examples they have created on their website. The first is ocean. Okay. It's saying whale whenever it is in the view. Train your app to detect marine life in tourist photos to help conservationists map and protect the ocean. This application is hand gestures. Train your app to understand the movement of your fingers. 1, 2, 3, 4, 5. This is a personal trainer. Recognize different workout. It's a rest, crunch, rest, crunch. This is about the baby monitor. Train your app to detect when babies are sleeping or awake, so that prompt action can be taken. Some other examples: safety precaution, mask, no mask. Train your app to monitor when masks are being correctly worn to help encourage proper safety precautions. Then you have fire watch. Train your app to detect smoke and flames using a remote area. Then it is smart checkout. Train your app to recognize different types of produce to help check out faster without the need to remember price lookup codes. Okay. Then it is tree, aerial imaging. Okay. Either you have forestry or you have trees. So deforestation or trees. So these are some of the applications they have built using lob.ai from Microsoft. This is the Lob interface. Okay. When you download and install the Lob application, desktop application, you double click on it. This is what you see to start with. The interface is very, very easy as you see on the left. You have the label, you have train, you play it. Okay. Play it or use it. So label is, you create the labels. Okay. Label 1, label 2, as over there in Teachable, it was called class. They will say label it. First label, second label, third, and so on. Then you train it, then you use it or play it for checking. So over here, you can import from the web camera or from your already existing images, or you can click, or you can dynamically create it. So these are the two applications. I would like all the participants to please use it. Now I'll go through the remaining slides. If the time permits, then I'll demonstrate. Or in some other time during your FDP schedule, I'll demonstrate both the applications from beginning till end. Next part is very, very simple. What I have told you, just go to the websites, download the application and use it. Within seconds, you will be able to use the application or the web-based application. Next part of my session is about explosive growth of AI. Since AI is applicable in almost all fields, they become the needs of our life. And it is the reason behind the explosive growth of AI. So we can divide the growth into two, in positive sense, in negative sense. Positive, obviously, useful to the society, harmful to the society. So this is the growth of AI. We'll talk about this. Our world will change more in the next 20 years than in the previous 300 years. It could be heaven or it could be hell. As of today, because of the explosive growth of AI, we see data everywhere. Data is everything. Cloud is everything. Everything smart. Everything connected. Anything you can compute. You can make anything. You can transact anything. You can see everything. So this is what we have as of today. To supplement natural intelligence with AI, for example, we are building intelligence in an object so that it can do what we want it to do. As, for example, robots, thus reducing human labor and reducing human mistakes. This is what we need. What some smart people are saying about AI. Steve Wozniak, Apple co-founder, the future is scary and very bad for people. Elon Musk, Tesla chief executive, AI is a damien that is potentially more dangerous than nuclear weapons. Bill Gates, Microsoft co-founder, I do not understand why some people are not concerned. Then we have Stephen Hawking, British theoretical physicist. Full artificial intelligence would spell the end of the human race. This is what some smart people are saying about AI. Is AI dangerous? Is it a good thing or a bad thing? What is sentient AI? Sentience means self-awareness, means human-level intelligence. Moore's law. It describes an important trend in the history of computer that the power will double every 18 months to 2 years. It was the observation made by Gordon Moore, Intel co-founder. The trend has continued so far and is not expected to stop for another decade. Even if a wall is reached, it is likely that some other way will be found to increase computing power, like quantum computers and all that. The plausibility of sentient AI, the Blue Brain project. It could be possible to model a complete human brain within 10 years on a single machine, no less. Ray Kurzweil, we will have both the hardware and the software to achieve human-level artificial intelligence with the broad suppleness of human intelligence, including our emotional intelligence by 2029. These are the statements. But what is the controversy? Should humans strive to build sentient AI? What are the risks? What are the benefits? Is it ethical or morally responsible? What rights should artificial beings have? Would there be any place for us along with them? This is the question. Sentient AI could be dangerous, as shown in I, Robot movie. Thinking for oneself. turn skills against humans, resent taking care of weaker race. Stephen Hawking, in contrast with our intellect, computer double their performance every 18 months. The danger is real that they could develop intelligence and take over the world. That is the issue. Sentient AI would take jobs away from humans. Around the neighborhood, in the homes, large number of autonomous vacuum cleaners, lawn mowers were in operation, as per United Nations. Medicines, computers are better able to distinguish signs of Alzheimer's than humans and prove cheaper, faster, and more accurate than current methods. The PC beats doctor in scan tests. Car industry, outsourcing is already a problem. Robot rights, ethical dilemma. If machines have the potential to exhibit complex behaviors such as altruism, language, and self-reproduction, questions of machine rights and robot liberation will surely arise in the future. Society's view on the rights of sentient AI. Is it right to create life? Is sentient artificial intelligence life? This is the question. These are the dilemmas. But all this is blown out of proportion. Movies such as I, Robot, Terminator, The Matrix, and many such movies, they take negative ideas and make them prominent. They give society a negative idea of sentience and AI. These movies are not accurate idea of the potential uses of sentience. What are the benefits of sentient AI? Benefits of AI will be more important than the very small possibility of these movies becoming a reality. Job loss isn't a bad thing. Take those jobs away which involve dangerous occupation. Depth of space for exploration into the unknown, which is a one-way mission. Biological limitations, purely repetitive tasks. Waste disposal means increase efficiency and overall benefits to mankind. So over there, job loss is not a bad thing. Sentient AI is beneficial. It is already being used in society, social, video games, intelligent force, industrial, smart assembly lines, mathematical, consumer purchasing prediction models, nanotechnology, smart patches, and medical innovations. Acquire medical information without even going to a doctor. Commercial, sentient AI would not fear doing more risky jobs, more safe work environment, reach to the areas previously inaccessible by humans. In education also. Some advantages and disadvantages. More powerful and more useful. New and improved interfaces. Solving new problems. Better handling of information. Information overload. Relieves from that. Replaces human repetitive and tedious tasks. Conversion of information into knowledge. Detection of frauds. The disadvantages are increased costs. A lot of money is needed to build, rebuild, and repair. Difficulty with the software development, slow and expensive. Few experienced programmers, AI programmers. A lot of demand is there for AI programmers. Few practical products have reached the market as yet. Machines can easily lead to human destruction if put in the wrong hands. Okay, so that is the disadvantages. Future of AI. AI will allow us to obtain or sustain a competitive advantage, 84%. AI will allow us to move into new businesses, 75% say yes. New organizations using AI will enter our market, 75%. Incumbent competitors will use AI, 69%. Pressures to reduce costs will require us to use AI, 63%. Suppliers will offer AI-driven products and services in the future, 61%. Customer will ask for AI-driven offerings. Yeah, so that will be the trend. AI and future of humans. What are the concerns? Number one, individuals are experiencing a loss of control over their lives. Okay? Black box type of thing. When people lack in code, they do not learn the context, how the tools work. They are just the users of that. Next concern is data use and surveillance in complex systems designed for profit or for exercising power. Okay? So company will be taking advantage of that power. Third is the AI takeover of jobs will widen economic divides, leading to social upheaval. That also is a concern. Next concern is reduction of individuals' cognitive, social, and survival skills. They are on the decline because of the use of machine-driven products. Fourth concern, major concern is autonomous weapons, cyber crimes, and weaponized information. Okay, so that also is a major concern, and AI is playing a major role in all this. What are the suggested solutions for the humans? Number one, improve human collaboration across borders and stakeholder groups. Number two is develop policies to assure AI will be directed at humanness and common good across. Third is alter economic and political system to better help human race with the robots. So with this, now I come to the last part about the questions. When will AI exceed human performance? How many years until a machine can do our jobs better than us? I'll come to the questions one by one. When will AI exceed human performance? So advances in AI will transform modern life by reshaping transportation, health, science, finance, and so on. Everything. For example, translating languages by 2024. This is expected. Writing high school essays by 2026. Driving a truck by 2027. Working in retail by 2031. Writing a best-selling book by 2049, working as a surgeon by 2053. They believe there is a 50% chance of AI outperforming humans in all tasks in 45 years and of automating all human jobs in 120 years. So this is the question and this is the expected response. How can AI transform developing countries? So three major sectors, in education sector, in healthcare sector, in financial sectors. Okay, AI can transform any developing country by taking applications in the education sector, healthcare sector, and financial sector. How are developing countries adapting to change due to rise of AI? I have shown 3-4 countries having a huge impact due to AI and automation. Change in infrastructure, change in education skills acquired, transitioning to less vulnerable sectors, change in policies. Okay. So this is how they are adapting to change due to rise of AI. Will the workers whose jobs are automated can easily transit to new jobs and how will it affect their wages? Okay. In mature economies, AI is automating tasks traditionally executed by humans. In developing economies, however, the rise of gig economy means that the nature of work is rather different. A lot of the jobs that AI might displace do not exist in abundance in emerging markets in the first place. Okay, this is an issue. If emerging economies were to adapt an AI-first approach, perhaps they could address critical development challenges such as finance, education, or health. It should be a priority of companies, countries, and international bodies to increase their focus on developing AI systems that are suited to driving systemic transformation in emerging economies. Our current approach needs to change. If it does, the societal and commercial impact could potentially be beyond our imagination. So this is the answer to the question. Developed nations are getting into an AI argument. Will this have adverse effect in the near future? How can AI be dangerous? Following scenarios, most likely, the AI is programmed to do something devastating. Autonomous weapons or AI systems they are programmed to kill. In the hands of the wrong person, these weapons could easily cause mass casualties. Moreover, an AI arms race could inadvertently lead to an AI war that also results in mass casualties. To avoid being corrupted by the enemy, these weapons would be designed to be extremely difficult to simply turn off once it is turned on. So humans could plausibly lose control of such a situation. The risk is one that is present even with narrow AI, but grows as levels of AI intelligence autonomy increases. The AI is programmed to do something beneficial, but it develops a destructive method for achieving its goal. Okay, so that also is possible. How long will it take until machine greatly supersede human level intelligence? There is a myth and a fact. Superintelligence by 2100 is inevitable. The myth is superintelligence by 2100 is impossible. It may happen in decades, centuries, or never. This is the fact. AI experts disagree and we simply do not know this. Second myth is only Luddites worry about AI. The fact is many top AI researchers are concerned. I have told you, Bill Gates and all those people, what they are saying, Elon Musk. Mythical worry, AI is turning evil. Okay? Mythical worry, AI turning conscious. But the actual worry is AI is turning competent with goals, misaligned with ours. Okay? AI has its own alignment, we have our own alignment. That is the actual worry. Next myth is robots are the main concern. The fact is misaligned intelligence is the main concern. It needs nobody, only an internet connection. Myth. Next, AI cannot control humans. Fact, intelligence enables control. We control tigers by being smarter. Okay, so that also is possible with robots, with AI. Next myth is machines cannot have goals. The fact is a heat-seeking missile has a goal. It is already created. Superintelligence is just years away. It is at least decades away. But it may take that years to actually develop it, to plan ahead. Will AI replace teachers completely? According to me, no. It will not replace teachers, but it will empower them in their profession. Lastly, a perspective. For humans, intelligence is no more than taking a right decision at right time. And for machines, artificial intelligence is no more than choosing a right decision at right time. I think artificial intelligence is the second intelligence ever to exist. Finally, the conclusion. Today, we have discussed about AI, some of its principles, some applications, some achievements. The ultimate goal of institutions and scientists working on AI is to solve majority of the problems or to achieve the tasks which we humans directly cannot accomplish. AI evokes both excitement and fear. I am confident that the opportunities outweigh the threats. If emerging economies were to adapt an AI-first approach, then perhaps they could address critical development challenges in finance, education, and health. AI is at the center of new enterprise to build computational models of intelligence. The main assumption is that intelligence, human or otherwise, can be represented in terms of symbol structures and simple operations which can be programmed in a digital computer. Within a decade, AI will transform school, college, university life and will give the biggest boost to social mobility our society has ever seen. Ultimately, combining the best of humans and machine for the benefit of learners is the true goal of AI. It is for sure that development in this field of computer science will change the complete scenario of the world. Now it is the responsibility of creamy layer of computer scientists and engineers to develop this field. Thank you very much for your time. Now you can ask if you have some questions. Demonstration I'll give next time. I'll talk to Dr. Sunil and we'll have some demonstration also for both the products. Okay, Sunil ji, Dr. Muskan?
Yes, sir.
Okay. You can take up the questions if you have.
So I've opened the chat box for queries. If anyone has anything to ask, they can ask them.
Muskan, I'll be putting these slides on the website. Okay. The website already in the first slide, the website was given. Okay. Participants can have access to the slides.
Okay, sir.
Okay then.
Thank you so much, sir, for a great presentation.
Okay, thank you very much. Thank you all the participants.
Thank you, sir. Thank you so much, sir, for your nice presentation and very informative presentation, sir. Sir, there is some glitch. I'm unable to just mute myself because of some internet issue.
No problem.
But sir, your presentation, your information is very, very informative and very helpful to the participants. And sir, I think that sir, you have second session. So I think that in the second session, the practical demonstration will help to all of us. Sir.
Go through the demonstration only. Okay.
Definitely, sir. Definitely, sir. So it would be great for all of us, sir. And sir, thank you so much, sir, for giving a very wonderful talk and discussing about the various aspects of the AI and its implications, applications, and the future scope, sir. Sir, thank you so much, sir. Thank you so much.
Okay, Sunil ji. Thank you very much. Okay.
So thank you, participants. I think that now the time for the lunch. So I think that we will have a 1 hour break. And now the third session will start from 2:30 on the same link. So thank you all the participants. We'll meet at 2:30 p.m. Thank you. Son, I'm audible.
Yes, sir.
Again, my screen is visible. Hello.
Yes, sir, visible.
And uh, uh, and photographs is
No, sir.
no, it is showing. Son, is it visible?
No, sir, it is not visible right now.
Okay. So let us complete. Sorry, the audience, for this inconvenience caused. So now we are on the that is a next, that is a IoT platform. So after talking about the various components of the IoT platform, so there are 5 popular general purpose end-to-end IoT platform that are suitable for the wide range of application. So here the IBM Watson IoT platform, Amazon Web Services IoT platform, Microsoft Azure IoT Suite platform, ThingsWorks platform, and car. So there are hundred of the IoT platforms available for a range of vendors. Some platforms are as mentioned here. So platform as a services aim especially the industrial IoT, and other IoT platforms are also focused on providing only a subset of the function that might be required for your IoT system rather than end-to-end IT platform solution. For example, Cisco and SaaS Edge to Enterprise IoT analytics platform, which is focused on IoT analytics only. As a result, you might choose to adopt more than one IoT platform. So just have a look. Have a look on IBM Watson IoT. So built on top of the IBM Cloud platform, IBM Watson IoT is a mature developer-friendly IoT platform, and with the strength in the real-time analytics and congregative computing, the platform also support device management, authentication, and and authorization, secure data storage, and the communication. Standard communication protocol like MQTT, HTTPS rules, REST APIs, and SDKs. So now these are some key features of the IBM Watson IoT. And now when we talk about the Amazon Web Services, so AWS, Amazon Web Services is known as the AWS, is highly scalable IT platform. It includes an SDK, authentication, and authorized device registry, a device gateway that communicate with the device using MQTT protocol, and this protocol provide a strong communication between the WebSocket and the HTTP, and the rule engine that integrate with the existing AWS services like DynamoDB. An interesting feature of the AWS IoT is a device shadow, which is a persistent virtual version of each device, including the last known state of device. So this is the some key features of Amazon. And now the third, that is a Microsoft Azure IoT. And Microsoft Azure IoT Suite is another comprehensive IoT platform which include support for device management and device twin, like device shadowing by using Azure IoT Hub, standard communication protocols including MQTT, AMQ, and HTTP, secure storage rules like the Amazon Web Services. Now, ThingsWorks, PTC ThingsWorks is an enterprise IT platform that support modern-driven rapid applications development. And in the same, that is the last one, that is a car. ACA is an open source IoT platform that is published under the Apache 2 license, which allow the platform to be hosted, to be hosted, to be hosted. And CA includes REST API and SDK for Java, C++, and C, with the feature for the device management, data collection, configuration management, notifications, data balancing, and the data analysis. So these are the some few key features and supporting protocols of these five renowned IoT platforms. And these five IoT platforms have a very good and rich market share. Now, the taxonomy, I think that through this you can see that the first architectural component of IoT is the perception layer, and this perception layer basically is basically a physical layer, and in this you can see all the physical things, and basically it connected with all the sensor, and these sensor basically sense or receive the data from the environment, maybe the neural sensor, maybe the medical sensor, maybe the environmental sensor, chemical and the biosensor, also infrared sensor, RFID sensor. Mobile phones have a lot of the sensor. So the first architecture component of the IoT is the perception layer. It collect data using sensor, which are the most important driver of the IoT. So there are various type of the sensor used in diverse IoT application, and the most generic sensor available today is the smartphone. And the smartphone itself has a many, as I told that it itself has a many type of the sensor embedded in it, such as a location sensor, that is a GPS, movement sensor, accelerometer, gyroscope, camera, light sensor, microphone, proximity sensor, and the magnetometer. So you can say that a smartphone itself have a lot of the sensor and have a different to monitor together the different kind of the activity, different kind of the data, and after definitely as per the taxonomy of the research in IoT technology, you can see that after getting the data that is from the various sensor, maybe the location sensor, maybe the movement sensor, or camera, microphone, light sensor, proximity sensor. So these are the basically belong to the mobile phone. So after taking this data, definitely it go for the pre-processing, and after pre-processing, definitely it go for the middle layer or the cloud, and then it reach to the application layer. So the pre-processing, when it go for the communication, so definitely there are various communications medium, short range, medium range, long range, and according to the your range of an communication, you have to choose your communication standard, which is known as the protocol, which we'll discuss. And here some protocols, low power link layer, adoptions layer, routing protocols, application protocol, and Zigbee protocols. Zigbee basically it's a network, and low power Wi-Fi, Bluetooth, low energy. So these are the various communications channel, and according to the requirement, we can select. And the middleware, cloud, and then application where there are various applications which perform the operation or analyze the received data. So many other sensors are so the sensors basically it's a very important component in the IoT technologies research. So now when we talk about the IoT architectures, what are the key components? So basically in the IoT architecture there are 6 key components, and this is 6 key components. So one, that is the device connection, and under the device connections you have IoT devices, IoT connectivity, and embedded intelligence. Now the second, that is the data sensing, how you are going to capture the data, then the sensor, tags, and storage, and the third, that is your communications. So definitely after collecting the data, then how you transfer the data. So focus on communications, access, network, cloud, edge, data transport, and now the fourth, after getting the data, then the data analytics, so big data analysis, AI, cognitive analysis, and the edge, and the fourth tip, that is a data value analysis to perform the actions after performing the analysis. Then how you take the action on the after the analysis. So actionable intelligence. So it's a very important. Actionable. And the fourth, that is a human value, that is a smart applications, stakeholder benefits, tangible benefits. So ultimately, whatever we are going to set up. So at the end of the day, these architectures, these IoT setups must give the ease of life to the human. So at the end of the sixth and very important component will be the human values. So these interconnections of the physical devices with the embedded sensing, communication possibilities, including the sensor and actuator, is nothing is new. So these are the very important component, and I think that in these component, the edge computing, the fog computing, the embedded electronics, and the software are also act as another next level important stages, and IoT gateway also. So which provide the additional connectivity technologies and the cloud and network and the IoT platform with growing integration of AI, IoT with other technologies, just like as a blockchain. So the evaluation in the IoT architectures is growing and fulfilling all the user need. So, but these six key components are important in the IoT architectures. IoT architectures landscape. So here the number of IoT devices and applications continues to grow, diversify, addressing problems specific to the different sectors or the verticals, and these include healthcare, agriculture, transportation, and so on. And different applications have a different requirement. Therefore, IoT system that underpin these applications become very complex and difficult to manage. So, as they need to meet all these potential conflicting requirements, in addition, some solution remain proprietary. Remember the philosophy of things, which we have already discussed in the previous modules or the previous session, means how the device talk to each other, means interaction with the device to device, and that further complicate the interoperability. So thus the IoT architectures design remain challenging, especially as a different stakeholder promote the standard with the different view of IoT. So it is also be well taken that the different stakeholders view and their rules, their standard must be taken into the consideration while proposing any IoT architecture. So standardization efforts are driven by the multiple entities that focus on different aspects of the IoT, include international bodies such as the Third Generation Partnership Project, CGPP, that is a concern with the mobile connectivity, or the Internet Engineering Task Force, IETF, that standardize Internet Protocol, collaborative research project. For example, funding by the European Commissions have worked on defining IoT architectures, as well as an industry consortium have been set up to address interoperability. For example, Open Connectivity Foundation. So the fact that technical document is scattered and often difficult to navigate. So, for example, the latest Bluetooth 5.2 specification is more than 300 pages. So, further complicate the adoption of a unified architectures, which work on Bluetooth 5.2 specification. So, it is also things to be taken into the care. And given the large breadth of standard, we will only cover the most important ones. and focus on the key principles that share while also looking at some practical examples. Now the key consideration of the IoT architectures. So, so there are many aspects, as I told, that to take into the consideration while deciding on what architectures to adopt for an IoT system. At a high level, the first thing that is considered is the range of our application that must be supported by such IoT architectures. And another, that is something very important, that is the as well as the requirement. So another aspect that must be allocated is how smart the different devices in a system are expected to be put into a right place. That is, will try to do more than sensing and transmitting the information collected. Yes, so placing, organizing the element things in the IoT is sometimes is more important than the sensing and transmitting the information collected, or they will do some processing maybe at the place of collection of the data, and can they be accessed remotely without the need of any intermediary network element. So depending on the applications requirement in terms of, for example, throughput and the latency, as well as the computational capabilities of the smart object, different networking technologies is chosen. So for instance, cellular communications are preferred when bundled delay are desired, while LOR might be used when the delay and reliability are not critical, and the volume of the data to be transmitted is small. So there is a instance or the case of smart agriculture scenario. So it is also very important. So oftentimes infrastructures serves multiple purpose and new features are added over time. This requires taking into the account how to design system that can be reprogrammed and managed easily. So nonetheless, the cost and scalable are important practical aspect. A system might be future rich, but very expensive to deploy and run. Cost can be impacted, scalability, but so do technologies specific aspect, such as a control signally specific to certain wireless technology. Imagine thousands of the devices contending for a channel access at the same time. As we will see in future modules, this can be drastically reduce the communication efficiency. So these things must be taken into the consideration. That means what applications domain you want to cover, what place intelligence to be placed, what networking structure should be employed for the efficient communications after taking the data, processing at the cloud, and then sending to the applications, how to modelize the system as to manage the complexity and enable the programmability, and what are the cost and scalability implications. So this is also one of the very important factors. Now the another, that is a architectures of IoT, architectures of IoT. That is, so there is now I have talked a lot and convey many things. As I told you that architectures, there is no a single consensus on the architecture for the IoT. So there is no single definition, single guideline, a single para. Now this is the architectures, and everyone have to follow this one. So architectures basically how to organize the whole system where you can efficiently take the data, pre-process the data, communicate the data, and then analyze the data. And after analyzing the data, then you have to take the action on that analysis, output of that analysis. So there is no single consensus on the architecture, or there is no single definition or the rule on architectures for IoT, which is agreed universally. So every researcher and scientist have their own way to define the architecture of an IoT. So different architectures have been proposed for the different researchers, but generally, so 3 and 5 layer architectures are commonly proposed by most of the researchers. The most basic architecture is the 3-layer architectures, and in this 3-layer architectures, applications layer, network layer, and the perception layer. So basically, the perception layer is the lowest level layer, and basically it's a physical layer. So the application layer is responsible for delivering the specific services to the user. It defines the various applications in which the Internet of the Things can be deployed. For example, smart homes, smart city, and smart health. And the second, that is the network layer, is responsible for connecting the devices or the smart things together, and network devices and the server. So how the component of an IoT they are going to connect, if we're talking about the device to device, device to human or human to human, how they are going to connect. So its features are also used for transmitting and processing the sensor data. The perception layer, basically a physical layer which has a sensor for sensing, gathering the information from the environment. It sends some physical parameter or identify other smart object in the environment. So this is the most basic architecture of IoT. Now another, that is 5-layer architectures, and here we are adding 2. So just see from from the previous one, application layer, network layer, and perception layer. But here, perception layer is here, application is here, but network layer again converted to the transport layer, and now added the 2 more layer, business layer and the processing layer. So 3-layer architecture basically define the main idea of IoT. But it is not sufficient for the researchers on IoT, because research often focus on finer aspect of the Internet of Things. So the 5 layers are perception, transport, processing, application, and the business layer. The role of the perception and application is the same as the architecture with the 3 layer, which is already I have explained. So the basic role of 3 remaining layers need to be discussed here. So the transport layer transfers the sensor data from perception layer to the processing layer, and vice versa, through network such as any wireless network, any cellular network, or LAN, Bluetooth, RFID, or NFC. The processing layer is also known as the middleware layer, and is stored, analyze, and process huge huge amount of data that comes from the transport layer. It can manage and provide a diverse set of services to the lower layer, and it also employ many technologies such as database, cloud computing, big data processing, and modeling. The business layer is something is very important. The business layer, the business layer manage the whole IoT system. The whole IoT system, including application, business, and profit model, and the user privacy. So these 2 addition is there, and which is very important, because the IoT in the IoT the business model play a very vital role, because it touch each and every sector. So the business layer basically manage the whole IoT so in which manage the applications, business part, profit model, and user privacy. So this is the now the logical view to the IoT. So the logical view to the IoT architecture. So this approach enable to break up the complexity, share resources more easily, and more easily, and prompt interoperability, basically. So here the architecture view logically separate the physical world, sensor or actuator, from the networking fabric, that connect the smart devices to the internet from software platform that enable managing IoT devices and the data they generated, and from the real applications where the developer seeks to build services that harness the potential of IoT without knowing the precise detail of a particular devices. So security and privacy are essential issues that must be taken into account across the different element of an IoT architectures and where possible end to end. So here I just see that here one more layer is added, that is a security and layer and privacy. If talking about the business layer, where you are going to talk about take care about the business modes, business system management, flowchart, but there security and privacy must be there. Application layer, different scale of smart application and management. Again, security is there. So security touch each and every layer. So platform, middle layer, processing layer, API, protocol, data processing, device management, database, and ubiquitous computing. So it comes into the middle layer or the processing layer where you are going to process the data, and then transport means that is the infrastructure or networking fabric. So transport or the network layer where you have to taken care about the connectivity, storage, Wi-Fi, Bluetooth, GB, etc. And the physical one, that is your perception layer, physical object, sensor, and actuator. So now, another that is something is very important. That is the advantages of the layer approach. So why we have to divide the whole architectures into the layer? What are the very benefits? So taking bottom of view. By this approach, the hardware vendors can focus on designing cheaper, smaller, and more efficient device while exposing standardized interface that high-level developers or the software platform can use. So at the same time, it becomes easier for the service provider to use network and computing resources without worrying about the details of underlying infrastructures, but instead focusing on developing API that abstract away low-level specific and build applications that serve precise purpose. So these are the key advantages. Means just to summarize, allow IoT devices manufacturers to focus strictly on improving their performance, power consumptions, etc. So how they can improve performance, power, and exposed to only these key area. Easier to share the partition strictly the network or computing resources, and manage network infrastructures or the network as a services. So in IaaS, NaaS, so infrastructure as a services, network as a services, and third, enabler software app developer to build application without having a understand or the specific of a device, that is a PaaS platform as a services. Now here we are going to talk about some communications model for the IoT architecture. So when you are going to interaction or this communication between the device to device, D2D, so wireless network, and the wireless network may be used or created Bluetooth, J-Wave, and GB, and there are two devices manufactured, A one device and there is another manufacturer B. So how to communicate? So definitely we have some set of rules, and these set of rules help to control these two devices. So device-to-device communication model represents one is sensing the temperature, another is sensing the carbon monoxide. So in device to cloud or the server model, the device connect directly to the internet cloud service like in the application service provider to exchange data and control mass system. This approach frequently take advantage of existing communication mechanism like traditional wired Ethernet or Wi-Fi connection to stabilize a connection between the device and the IP protocol. IP protocol of the network, which ultimately connect to the cloud service. So here we are using the different set of protocol, HTTPS protocol, TLS protocol, TCP protocol, IP protocol, CoAP protocol, DLS protocol, UDP, user datagram protocol, and IP, Internet protocol. So these are the some protocols which are used. So CoAP basically constrained application protocol and user datagram protocol. So these are the different protocol which is used to transfer the data from the device to server. Now the next one that is a device to gateway model. So in this device to gateway model, or more typically device to application layer gateway (ALG) model, the IoT device connected through ALG service as a conduit to reach a cloud service. In a simpler term, we can say that this means that there is an application software operating on a local gateway device, which act as an intermediary between the device and the cloud services and provide service and other functionality such as data or protocol translation. So several forms of this model are found in consumer devices. In many cases, the local gateway device is a smartphone running an app to communicate with the device and relay data to a cloud service. So this is a often model employed with a popular consumer items like personal fitness tracker. So here you just see that there is a protocol stack, and here there is a gateway, and through gateway you are connecting with the application or the cloud. So your device to gateway model. So you are connecting device to the application via gateway. This is another communication model. Now the third, back-end data sharing model. The back-end data sharing model refer a communication architecture that enable user to export and analyze a smart object, export and analyze smart object data from a cloud service in combination with the data from the other sources. So this architecture support the user desire for granting access to upload sensor data to the third party. So the four basic. So in these four basics, so here the light sensor and application service provider and application service provider SU and application service. So there are a number of application service provider where you need the authentications to share the data to the other platform. So in these four basic communication model demonstrate the underlying desire strategy used to allow IoT devices to communicate. Aside from this, some technical consideration. The use of this model is largely influenced by the open versus proprietary nature of the IoT devices being networked. And in the case of the device to gateway model, it is primarily feature is its ability to overcome proprietary devices restrictions in connecting IoT devices. So this means that device interoperability and open standard are the key consideration in the design and development of inter-network IoT system. And in this way, every model has their own unique properties and model and the standards. Now, next, that is IoT communications. So when we're talking about the IoT communications, so addressing and identifications, low power communications, routing protocols, high speed, and mobility. So as the Internet of Things is growing rapidly, there is a large number of heterogeneous smart devices connected to the Internet. IoT devices are battery operated with the minimum compute and storage resources. Because of this constraint nature, there are various communications channel involved, which are highlighted here. So, so first, that is the address and identifications. Million of smart things will be connected to the internet, and they will have a identified through a unique address. That is the you can also say that the IP address on the basis of which they communicate to each other. So for this, it is just similar like the in internet. Whatever you are going to access, whatever you are going to allow the other person to access your data, definitely you have a unique number, a unique identification for the network, so that people can search and access your data. For this, we need a large addressing space and unique addresses space to each smart object. And you know that the growth of devices is very fast, and not it is fast. It is fast as it is more fast as compared to the population. So at one moment, the world population is lesser than the population of IoT devices. So if we have such huge number of IoT devices, definitely the size of unique address is also be very high. So our addressing and identification scheme must be very well defined. So that's why here IP version 6 using, because IP version 6 have a very huge addressing scheme. So low power consumptions, common communication of the data between the device is a power consuming task, especially wireless communication. So therefore, we need a solution that facilitate communication with the low power consumption. A routing protocol with the low memory requirement and efficient communication partner. High speed and non-loosey communication means we need a reliable communications, means no any any break or any delay in the communication, and speed is also very high, and mobility of the smart things. If the sensor are able to move, so how you connect with the mobility of the smart things? Now that is another which is very important to understand the cloud versus fog versus edge. That is the information processing wave. So different IoT architectures can be considered based on where most of the computing reside and where the data is acted on. So basically, when we talk about the cloud computing, so cloud dominates the network system landscape until recently. All the intelligence on powerful servers, including the relational database, control functions, data analytics engines, web interface, etc. Any devices merely information gathering in cloud computing might not scale as the number of IoT devices grow. The applications continue to diversify and generate more data. So this as I told you that the number of devices grow, now the applications emerge all time, and the volume of data generated by the IoT device is sky rocketing. Means the number is boom very high. The cloud computing paradigm faces scalability challenges. So these include growing cost associated with the routing and storing big data, and the control signaling overhead incurred by the billion of the devices that may compete for resources with the data traffic. At the same time, since all the data processing is performed in cloud, these introductions latencies must not be appropriate for the application with the real-time constraint. So, just taking an example. Example of smart metering and means smart meter, and in a home there are two electric meter and gas meter. These two meters have a sensors to take the data of electric meter and the gas meter, and these data are collected or connected with the home hub, and then through this radio access network, then your core internet, and then other side your cloud infrastructure, energy supplier, energy operator, and the third party. So sensing performed by a simple sensor, informations relayed by the home hub over cellular network, and data processed in the cloud by different stakeholders. So Now, in fog computing, so pushing some just so so in fog computing, pushes some of the data processing functionality closest, just try to understand, closest to where the information is collected. So the fog computing basically pushes the data processing. So the data processing not at the place of data collection, but at the some closest place where they perform the data processing functionality closest from the where information is collected. So this can be dedicated node in the access network that can IoT device to the server running application fulfill the relevant data. The type of functionality that is offered to fog node may include data aggregations and compression, some degree of processing, computing, statics, removing nodes, etc. And optionally acting local on the on some of the data, some of the data process. Example, switching on and off a boiler if thermostat indicates certain threshold was passed. So IoT devices are not expected to have considerable computing power or the storage in this setting, nor a unique IP address. So that could allow for a direct remote control. So this permit to preserve the low cost and the battery powered operation of the IoT devices. So as move some intelligent further from the cloud, the resources must be managed with finer granularity, and this turn the management tasks into the applications that run at the different point of the system architecture. So pushing some of the intelligent closer to the device. This include data aggregations, compression, and processing, make localized decision, and IoT devices kept simple, no direct communication with the end sensor, still battery powered, resource management implemented across the different network. Management would be regarded as the application. So here we are managing the things very fast. So ultimately in the fog computing, we are reducing the delay of the communication. When you are reducing the delay of the communication, definitely the performance to be improved. The role, so the role of gateway in fog architectures. So data filtering and processing. For example, aggregation of the summaries, compression, protocol translation, and interfacing between the different connectivity technologies, data flow, multiplexing, packet routing, security, for example, data encryption and firewall, and scalability problem. As the number of devices grow, so will the number of gateways that are required. So you maybe notice that the gateway and fog nodes play an important role in fog computing. So IoT devices, so basically, for example, if we just take an example, so IoT devices might communicate using BLE technologies to save power and has a short range, and the server processing information for such devices do not implement BLE. Translation and interfacing go hand in hand with the packet routing. And another functionality that can be implemented by the gateway is security, including the strong data encryptions to preserve the confidentiality and firewall. And the last, that is the fog concept can be distributed the cost of data processing and reduce the communication latency. As I told you, the key part of this, that we have to reduce the communication latency. And when we are going to reduce the communication latency, definitely it may affect, it have a great impact on the performance. So some applications require the data immediately. So for such application, the fog computing is very beneficial. So just take another example, that is a home automation. So in this home automation, So you know that in the home automations we have a lot of the home appliances, and we are trying to connect each and every home appliances. Now in home we have AC, we have fridge, washing machine, light, TV, fans, kettle. So now all these things are connected. All these things are connected. Just wait. All these things are well. These internet from where you are getting the data on your cell phone, you also cloud services. So home automation systems are the fog architecture, example of the fog architecture, the home gateway interface between the different appliances that may be communicate over Zigbee, Wi-Fi, and other wireless technologies, and a fiber link that connect home to the internet, and data to be pushed to the cloud server for more advanced analytics if you require. So user can control the IoT device in their home either via their home Wi-Fi network or remotely via yeah. So same thing. If you are in home, you are connected with your Wi-Fi. So locally you can control your devices, or remotely through the cellular 3G, 4G, 5G connectivity. You can connect. So gateway perform the protocol translation, incorporate the basic network institutions integration system. Cloud services continue to perform analytics. For the now the smartphone as a gateway. The smartphone as a gateway. Why we are saying this? Because current smartphones have enough functionality to act as a gateway. In certain application scenario, for instance, with the wearable and the medical devices, this is reasonable given the ability of the smartphones to communicate over multiple wireless technologies. The fact that they run a full-fledged operating system and a complete TCP IP stack. So why the smartphone act as a gateway? Because it have a full-fledged operating system and the complete a full set of TCP IP stack that facilitate internet services and also enforce security at the different layer of the networking stack. That is something is very important. And in essence, they bear the considerable computing power, and then I think that the ARM Cortex microprocessor, processor which perform the computations in such smartphones. So that permit the execution of the sophisticated tasks, including the data pre-processing, augmentations, addition informations available on the phone, example GPS coordination and other things. So embed multiple networking technologies first. That is available with every gateway. Run full TCP/IP stacks, thus maintain end-to-end connectivity with the cloud. Can connect to multiple devices within the close proximity simultaneously, and ability to enforce secure transportations and sufficient computing power to pre-process augmented collected data. So in this way, we can say that a smartphone have all capabilities to act as a gateway. So, for example, wearable devices. For example, wearable devices. So, therefore, the wearable devices scenario whereby a user has a smart shoes, smart glasses. In this picture, smart shoes, smart glasses, smart fitness tracking wristband. Each of these specialize in one or more sensing take and for example, accelerate heart rate and video capture and transmit the data collected to the smartphone over BLE. In turn, the phone communicates these cloud-based services possibly after some degree of pre-processing. Such services could monitor the long-term fitness or the sleep quality of the user, even assist in tasks such as navigation and facial recognition. So, smartphones communicate over clearly with the wearable devices, perform minimal information pre-processing, relay data, cloud-based services. So, here, the wearable devices, we can say that act as a gateway. Now, another that is we already discussed the cloud fog. The third one that is the edge computing. That is the edge computing. So the microprocessor, the pushing computing power. So in edge computing, pushing computing power, we are the communication capabilities, intelligence down at the device level. So when it's come to the device level, definitely the microprocessor role is more critical and centralized. So the microprocessor become increasingly more powerful. Their footprint is smaller, and overall the number of IoT devices grew. Another that is gaining momentum is that of age of computing. That's edge computing. So the core philosophy is to embed as much compute and communication technologies into a smart devices, so as to process most of the data precisely where it being collected. So the objective, again, in cloud, the data transmission delay is rare enough, and to reduce this delay, we have to go for fog computing. Means now the computation is not at the place of data collection, but very near to the data collection. But in edge, we are perform the computation at the place data collection. So here we just try to the communication delays into the smart device. So process most of the data precisely where the data to be collected. So this being this clear benefit of real-time applications that require low latency. So when we compare these three computing paradigm, cloud computing, fog computing, and edge computing, so definitely the latency, the application latency is often is very low in edge computing as compared to fog, and in fog the latency is low as compared to cloud. And when we are numbers in the performance, so often we need to act the data without external control. So at the same time, reduce the sending or communications cost, because you are not sending the data to the outside. So and device are able to decide what key informations need to be stored for long-term use and therefore transmitted. So processing much where the data is transmitting only the key informations are summarized, because you are performing communications at the collection level, enabling new applications, automotive, IoT, virtual, augmented reality, and in-ear computing. So a new wave of applications emerge with the edge computing, include the autonomous vehicles, virtual and augmented reality, or in-ear computing, all of which strive the more personalized user experience. So just here, when we talk about the another example, that is a hearable things in your ears to listen something. So several technologies advances bridges edge computing applications such as to reality. To begin with, multiple sensor along with the low power, high performance CPU can be collected on very small chip. And flagship example is the ARM Athons design that can deliver 1 teraflop per second, 1 tera operation per second and within the 1 mm2. So just you can imagine the computing power when we are talking about the edge computing. So secondly, the software libraries have been developed that can be used for AI inference on IoT devices. So such in case, uTensor library that built on Mbed operating system, which is already discussed, that is a open source platform where you can get all the tools, library in the open source form for the development and creating a IoT infrastructure or environment. So, nonetheless, the scenario is also made possible by recent research effort that seeks to reduce the complexity of a neural network model so as much capabilities of embedded hardware. So, these include model compressions and the model pruning. Why we are going to choose this what are the basic criteria to select a right IoT architecture? So as I told you that there is no universally defined definitions of the IoT architectures. So every researchers have their own. So deciding on what best IoT architectures is for an require considering a couple of factors, but ultimately it is to the performance. So at the end of the day, everything is related to the performance. So we have to we have to select those architectures where we can get the maximum performance. So that is the key requirement. And another, the cost of the solution is also important. So these translate to how much to invest in computing power, where to place that, what are the internet working costs, whether the data should be acted locally or passed to the fog nodes or to the cloud server. So orthogonal to all these aspects is the system where the trust boundaries can be drawn in order to make an appropriate security or data confidentialism. So these are the some key parameters. So as I discussed, that is cloud server, fog nodes, and edge nodes. And when we just see the scale up, so thousands, millions, and billions. So what are the applications requirement? What kind of what data need to be acted on locally? You processing at local or the remote, and what is the most of the compute? Where is the most of the computing power? You have to take, if you require computing power more, then you have to go for edge, but if you want to do less, then you go for the cloud. How much network infrastructure should be deployed and used? It is also one of the key parameters because the cost and the time means when you are going to transfer the data from one. So this will also taken care into this one, and where the trust boundary, that is the security and the data confidentiality. So these things must be taken into the consideration before taking a right decision on selecting. So this we have to talk about the standard. We have to talk about the standard for IoT protocol. So multiple regulation bodies and industries alliances are standardized the mean by which devices can interact with each other and with the gateway or cloud or others. So as I told that when you are going to connect, definitely you have to follow some set of rules. So IoT encompasses a vast amount of technologies that ensure device and software development by the different parties can interoperate. Standardized communications protocol and interface are essential. The landscape of a standard relevant to IoT is broad, and there are different entities that standard. The constitution of engineers define a lot of the standard for this kind of the set of rules and the communication between these two. So here, the primarily dealing with the defining protocol for the wireless, targeting the industrial, scientific, and medical, and 2.4 gigahertz, 5 gigahertz, 19 megahertz in some regions. Most relevant with IEEE 802.15.4, on which ZigBee build and IEEE 2.11 AH implement to the IEEE 802.11 specifications typically used for Wi-Fi that enable the low power wide network. So this is something the standard for the protocol. Now the third generation partnership project. Just the third generation. So another standardized body is the 3GPP, the partnership project, and this body recently have been focusing on defining communication standard and architecture for cellular voice and data networks such as GSM, 3G, 4G, and long-term evolution LTE. So recently, 3GPP has also developed a standard that specifically target IoT applications, in particular LTE, and has been defined as the extension of LTE to support low power wide area networking, the LP1. And you know that when we're talking about the IoT is one of the key factors. So they define another standard. With the name that is a low power networking type communication, MTC and IoT. Unlike competing LP1 technologies, it offers higher throughput up to the 1 Mbps. And that technology is defined by the GP, that is a narrowband IoT, NB-IoT, that offer the lower capacity and employ the different modules and the porting scheme for the uplink and the downlink. And the lower capacity is up to the 200 kbps per second, and different modulation and coding schemes are there, and it does not require any gateway. Now, that is engineering task force. That is a international body that is like a IEEE, like a 3GPP, that undertake a lot of work relevant to the IoT domain. Is IETF. Historically, IETF have been focusing on specifying protocol that govern internet operation, that is a TCP/IP, and from IoT point of view, much of work has been done to enable constrained device to use IPv6 Internet Protocol version 6 addressing, such as the case of 6LO, low wireless personal area network, that introduce encapsulation and header compression techniques, so that IP version 6 packet can be exchanged over IEEE 802.15.4 based network. And similarly, it also defines the role for routing mechanism. And another is to facilitate end-to-end messaging between the IoT device, as well as their management. IETF define protocols such as MSAT that uses the publish and subscribe paradigm, and COAFs, COAFs, as I mentioned, that MQTT, that is a message queue, telemetry transport, and constrained actions to enable the integration of IoT device with the web. And protocol such as POPs use the user data protocol for the transport due to its connectionless nature and low overhead incurred to prevent the tampering which with the search transport protocol. So IETF has defined datagram transport layer security, DLTS, and device lifecycle management is another important aspect in IoT. And IoT establishes a working group that seeking to standardize software updating for IoT, that is a SUIT. And the third, that is in addition to the standard, IETF also publishes information document and experience-based guides that relevant to IoT. For instance, RFC 8259 removes inconsistency with the other Jones specification and repair errors. So this is this one. Now another industry alliance, Bluetooth wireless personal area network, weapon defined application profile, ZP wireless personal area network building the on IEEE 0.15.4 inexpensive consumer industrial applications and low power wireless area spread spectrum technology. So standardization is also driven by the industry alliance and consortium, such as the case of the widely used Bluetooth specification, of which 5.2 revision has been recently. Bluetooth is a wireless private area network by technologies, and that will be defined later. Collaborative association have also been set up to encourage research and development in IoT, including the Alliance for IoT Innovations. That is organizations around 11 working groups: IoT European Research Cluster, Innovation Ecosystem, IoT Standardization Policy Issues, Smart Living Environment for Aging Well, Smart Farming, Food Security, Wearable Devices, Smart City, Smart Mobility, Smart Environment, Smart Manufacturing. There are so many others. So another example is OCR that gather the 300 members, including the large organization whose primary mission is to develop the open implementation that allow IoT interoperability. So this is the notable contribution by these standard industry alliances. So now there are other standard bodies that have been released specified specification already used by the IoT system. For instance, National Institute of Standard and Technologies work on the range of science, technologies, and engineering topics. For example, Advanced Encryption Standard AES, International Organization for the Standardization ISO, promote a broad range of proprietary, industrial, and commercial standard. Example, Internet of Reference Architecture, so IEC 30141 218, and another that is important, that is the International Telecommunication Union ITU recommendation references model. Example, ITU TY 4000 /Y 2060 overview of the Internet of the. So these are the different standards defined by the various other organizations. Now these are the various IoT all stacks. So as a result, the number of internet devices are growing, and when the number of devices is growing fast, so definitely we have to define their rules and standards. So this is a very huge numbers, and IoT protocol layer wise. So when we as a TCP/IP layers, so application layer, applications layer, so where as application layer protocol that intended for the resource constant internet devices, and MQTT, that is as I told you, that MQTT protocol enables the publish and subscribe messaging model in an extremely lightweight way, and it is useful for the connection with the remote location where a small footprint required, and our network bandwidth is at premium. So the leading communication technologies used in the IoT world are IEEE 802.15, low power Wi-Fi 6 LO W-band, IP version 6 over low power wireless power network, RFID, NFC, Sigfox, LoRaWAN, and other proprietary protocol for wireless network. So here some other protocols defined as a protocol for the data communications, constrained application protocol, COP, as I discussed, MQTT, message queuing telemetry transport, which is invented by the IBM 2002. Telemetry applications using the low power data rate and require a small footprint and low bandwidth. Another that is a IoT protocols local network communications IEEE 802.15 is a standard which specifies the physical layer and media access control for the low rate wireless personal area network, and it is used with the IP version 6 low wireless private area network and the extended internet protocol to build a wireless embedded internet, which is already discussed. So ZB, it is another local network communication standard used 802.15.4 is standard to operate at the 2.4 gigahertz frequency range with the 250 kbps, and the maximum number of nodes in this network is 1024 with the range up to 200 meters. So ZB can be used 128-bit AES encryption and Bluetooth low energy Bluetooth low energy. That is another local network communications standard designed and marketed by the Bluetooth interest group. Different profiles for the different applications. The technologies used to send contextual information based on the low-case Google background platform, Google Physical Web, Apple background. So are some examples. And the low wide area network LP1. So it's a weightless and IoT, MTC, LT type communication protocol, and extended coverage TMT. So these are the some other standard rules and protocols which is used for the low power wide area network. Means the devices which is operated on with the minimum power and maybe work on a so Sigfox. This is another that is a French company that built a low power wide area network for device using the proprietary protocol, and another protocol that is a network protocol intended for wireless battery operated things in regional, national, and global network. So it is managed by LoRa Alliance and random phase multiple access technology communication system, employing direct sequence spread spectrum with the multiple access. So now the routing protocol IP version 6 over a low power wireless personal area network, which is donated by 6 low wireless band, which is already discussed, and another that is a RPL, that is a routing protocol for low power and loosey network by IEFT role working group and ideal for N2 1 links. Means that is a meter. These are some stacks of IP version 6 low power wireless personal area, and here in the coming sessions tomorrow we will talk about the during the 4 to 4:30 we will talk about the Raspberry Pi 4 and how this code is helpful to learn and understand the various characteristics of the IoT. And as I told you that this is a computer and the basic. We can say that this is computer on the to give more wide spectrum of programming, more software-oriented programming, and yes, this can be connected full networking system. So we can connect with the network to transfer data or take data from the remote or send it to the remote. So how the system means we have to describe each and every part of this Raspberry Pi and how Raspberry Pi to be configured, how the Raspberry Pi to be installed, and then how a small project or how a program could be created in under the Raspberry Pi 4. And as I told that it has some basic pins. As I told that there are 4 parts, that is a data acquisition and control. So for the data acquisition and control, they have a general purpose input output pins and logical level voltage, that is this. And another, that is data processing and sortage. So it have a R Cortex A72 processor, and which have a processor speed of 1.4 gigahertz. And now the memory, it comes with the 1 GB RAM, 2 GB RAM, and the 4 GB, and up to the 8 GB RAM. So you can take the Raspberry Pi 4 with the 8 GB RAM, but we have the Raspberry Pi 4 with the 4 GB RAM, and it have the, as I told you, the network capabilities. So network interface is there. So through that you can connect with the Wi-Fi, Ethernet, or the Bluetooth, and the power. So recommended power supply is operated on a very less power. So physically will show this chip, and physically will configure the whole things, and how these chips to be run and customized in the coming evening session, that is in the last 4 to 4:30 session. Here, that is conclusion. So overall, the IoT standard landscape is extremely complex, and deciding on which of these to use for a particular application is not straightforward. And this is a map drawn by the various organizations, industry alliances, to define the IoT standard that seeks to the place of different specification and the standardization body according to their relationship with the connectivity service aspect and respectively their business dimension. So a lot more need to be happen in this area of IoT application and communication technology. So these field will definitely mature and impact human life in inconceivable way over the next decade. And this is a very growing field, and where every design their own architectures, define their own standard in which they can learn data. But in all cases, they must ensure the privacy and security of the data, so that the trust build up toward the IoT system can be. I'm just concluding my presentation. So I request any questions from the audience. Hello, Muskan. So,
Yes, sir.
Muskan, any questions?
So the chat box is open and
And now it is disconnected, and again, I have to rejoin. So, any uh, or we can close. So Muskan, any questions? So I think that thank you so much, all the participants, and I will share all the PPTs as I told you that. And today there is some technical glitches happened during these sessions, so I'm extremely regret for this, and we'll look into this one that why it has happened because. Uh, Video is not coming while sharing the this PPT because in day things are going well. So there are some glitches. So for that, sorry for that one. Muskan, if any question, if any participant want to discuss anything, so if they can raise their hand, and because now we have a 15 minutes more because the last session that is a 4 o'clock or 4:30, we have a review discussions about the and the feedback also because the feedback is mirror for all of us for us and definitely the person feedback is very important, very valuable for me. So in this half hour, if any participant want to share, if any participant want to or discuss or share some thoughts, it's a wonderful for me. So Muskan, please, if anyone want to share anything, because the sessions are completed, so all the sessions are completed. So if anyone person may want to leave, they can go. But we have a half an hour discussion and session where we have to discuss what we did and any specific requirement, any specific suggestion, or any specific discussion on the technologies we can do. So all the sessions of the today are done. So any suggestions from anyone? Muskan, are you I'm audible?
Yes, sir. Yes, sir.
Okay. So first, someone feedback after completing the all the session. So feedback will be given on the AICTE portal. So that will be there is no separate feedback form. There is no separate the feedback form after completing the FDP and giving the quiz. Then you are able to submit your feedback.
Good evening. May I ask something?
Yeah, please.
Sir, thank you so much for providing valuable information regarding the IoT. As a student of computer science and engineering, currently I am doing PhD in NITTR Chandigarh in the field of IoT machine learning, sir.
Great.
Thank you. Sir, it's a very important session for me that as well as for all those I consider that is doing research in the same field. That is the most demanding topic I think in my.
Yes.
Sir, I just want to know from your side, being as an expert, sir, I just want to implement some machine learning type things on the fog node. How is it possible?
Because one thing is, as I told you, that the basic objective and the basic lead, that how we enrich the knowledge of machine or the system or the device or at any age, that the device and the things itself is capable to take the decision. So at the end of day, we want to minimize the human intervention. I think that in the initial days, you heard that the computer system comprises with the software, hardware, and user. But because of the AI, because of the machine learning, because of the deep learning, we are enriching the knowledge. Means we are minimizing the intervention of the person, and we are enriching the knowledge of system. The system itself have a capabilities to take the decision. So yes, regarding the IoT and the machine learning, it's a well-versed, and I think that in the coming session, one topic that is Professor Madam Savita Gupta will take regarding the machine learning and the application of the machine learning in healthcare system. So I think that that session will be very fruitful for you, and because in healthcare system, the application and the use of IoT is huge, and in that one, the IoT taking the data and analyzing the data, and after analyzing the data, definitely they take the decision on the previous. So in healthcare system, you can say that if the things, if the technology is moving in this space, so I have no doubt that after some times the IoT devices take the role of the doctors. So IoT devices, after taking the data or disease data of a patient, the IoT devices can suggest what will be the next future course of action in the terms of medical advisory. So yes, you can do that. There is no second thought. Anybody else? Muskan?
Yes, sir.
Anybody else? Any other questions? So, if anyone wants to ask, they can raise the hand. I think that Muskan, Rajiv Chaudhary sir, I think that has raised the hand.
Oh, yes, sir, I have enabled the mic.
Rajiv ji,
am I audible, sir?
Yes, perfectly audible. Please, how are you?
I'm good, sir. How are you?
That's great. That's great.
It was wonderful session. I learned a lot, and I'm also doing my PhD on this particular topic, IoT with cloud. Sir, I just want to ask one thing: can we merge edge computing with fog computing, just to make a kind of hybrid system with both the computing?
Your voice. What do you want? You want to merge the computing of
edge computing and fog computing. Can you merge
edge computing and Rajiv ji, as I told you that, basically when you are perform the computation, so computations actually when you have some information, have some information and you are processing, and after the processing you are transferring the data to take the decision or on any application. So when you are going to merge, because each and everything have their own identity, and every identity is definitely related to the requirement. So suppose that you want the maximum performance, means you want to perform the computations at the place where you are taking the data. That is your edge, means take the data and then process. But if you're not interested to process because of some challenges, maybe the challenges of hardware, maybe the challenges of the power or some other things, or the computing. So you are sending maybe security also. You don't want to process the data. You don't want to give some result at the edge. So you are just taking the data and sending the data to the some other devices, some other places where you are going to perform all those things. So that is your fog. So basically, these two terminologies is relate with your delay. So you can sacrifice with the delay, then go for the fog. If you cannot sacrifice with the delay, you want the computations right now, then go for this edge. And in the cloud, definitely the delay is more. The delay is more. So it depends on your requirement, what you want. And definitely it also relates with the security of the data, safety of the data. Because you are taking the data, you are not computing, you are not analyzing, so there is no meaningful data. But if you're performing the computation at the receiving end, So it may that what kind of the computation you want to perform for what application. So we must be very clear the purpose and the objective of the IoT. Then we can say that this. But these three things are defined to just say that the edge have their own properties, fog have their own properties, and cloud have their own properties. So I think that when you are merging means minimizing the delay. So if you are merging, then fog. Because there is a Rajuji, I think that it is very good. There is a discussion because everything every object have their own identity, and we are mixing with the object and then we reach to the conclusion. I think that there is a word I would like to discuss with all of you that and it's a great opportunity for me also that I'm going to interact or have an interaction with all the faculty members. We are talking about the data processing, and sometimes we are telling about the information processing. So my one question, we can say that give me discussion that what we do, the computer process the data or the computer process the information. Means what we are getting the information through the IoT or through the sensor, or we are getting the data.
No, sir, exactly. We are getting the data always.
We are getting the data always. Now this is a very interesting. This is a very fundamental. I think that this question is relate to you. Relate with your question. Data.
Yes, sir.
Okay. What is the meaning of data?
I mean, I am pretty much sure about what computer or sensor or electronic device can do. It's only always take the data, not information.
Any other person? The forum is open because I kept this half an hour for this kind of discussion. It's a very important.
Can we get this PPT and the recording?
Yes. You will get each and everything. Yes. Whatever the session we are holding, the YouTube live of each and every session is also there. Because why we did this? Because we received many requests from the many participants. They are in the waiting list, and I feel so sorry that I could not accommodate because AICTE has a limit of 200 participants. So I cannot allow more than 200 because the AICTE software allow only the 200 participants. So that's why, for the benefit of the knowledge, whatever we are doing, that to be transmitting live through the YouTube channel. So whatever the session we are conducting here, the whole things to be transmitting live, and the YouTube link of the live is also shared with the WhatsApp group. So Muskan, once again I request you that please also share the YouTube link also, so that those who are in the waiting list or those who want to learn about the something from this session, they can hear. So data and information. Actually, what I feel that when we are talking about the data, if anyone, any others can enlighten something on this point, on this discussion. Muskan, some other. I think that Mr. Upadhyay, sir, is also raised the hand. So those who are interested to share their thought about the data, because data and information, what you are talking, it is a prospect, but there is two things. One, that is the identity of any object or the concept have its own fundamental. So I'm talking about the fundamental perspective of the data and information. So when we are taking the data from this IoT, from the sensor, so we are taking the data or the information. Hello.
Hello. Good afternoon, sir.
Yeah. Good afternoon. How are you, sir? How are you, sir? Yes. You are perfect. You are audible. Please speak. Rajiv ji, you can hear me? Rajiv ji?
Yes, sir. Yes, sir. Yes, sir. I can hear you. Yes, sir.
Yeah. Okay. I think that Mr. Upadhyay sir is talking. Mr. Upadhyay sir, are you? Your mic is muted. Your mic is muted. Please unmute your mic, please. Muskan, just see.
Yes, sir.
Many of them is calling. I think that I don't know. I think that in chat box I am just looking that information attendance link has been shared. Attendance is already recorded here. Muskan, attendance already recorded here, na?
Yes, sir.
And we will share the update.
Yes, sir. We can take another question from Viraj Upadhyay. Yes, Viraj Upadhyay, you can ask question. Viraj Upadhyay.
Hello, sir. Good afternoon. Am I audible to you?
Yes, sir.
Yes, perfectly.
Yes, sir. You can ask question, sir.
I think that Madam Meenakshi has written data is raw and information is processed data. Means as per the Madam, as per your statement that input is data and output is information. Because data is raw and information is processed data. So after the processing, what the output we are getting, that is a information. Can anyone tell me one answer? That is can you tell me the number of data types? Anyone? The number of data types.
So basically, there are two type of data type. First one is built one, and second one is user defined.
First one is
inbuilt data type. It's already compiled
data type. Okay.
And user defined data type. That is a broader perspective of a data type.
You are categorizing the data types. I am talking about the total number of data types. How many data types is defined correctly? Can you suggest some figure or because when you are saying that the user defined or system defined, system itself is made by the developer, and developer is also the part of the user.
So then it would be it would be integer character and simple, nothing else. Integer character and real.
Okay. Means you are saying that the three types.
Yeah, exactly.
Okay. And anyone else? It's a very interesting. I think that it's an open book question. I think that there are two questions I am just given to all the participants that when you are taking the data, one thing is very important. To understand the concept fundamentally, it required a lot of attentions and lot of reading because to this FDP we are just touching the points because we know that in this 1.5 hours we'll try to collect all the required information and required topics and how the things are connected to each other. We are just sharing the starting point, just like as a link node. The starting point we are sharing, okay? so that you can move into the right direction. And when you are moving, definitely will guide how to proceed, how to do the things in that one. So understanding about a topic is very important from its depth. And for that, we never run behind a very big words. Again, I'm asking very two things, very basic things, very basic things. That is a data type, and when we talk about the data or information. So in IoT, the morning session, in the after session, I think that I've reported sensor too many times, and every time I'm saying that sensor are getting the data, and data is processed locally or just near to the location, near to the place of getting data or some other places. So according to that, we define the architecture. So that's other. So basically, these two. If we know the answer of these two things, definitely a lot of the concept, lot of the fundamental concept will be clear. Okay. It's an open book. It's an open book, and it's an open book question. These two questions is open book. Please, my number, mobile number, email ID is there. So I am open to discuss with all of you on these 2 points. So I think that now the time is 4:30, and so the remaining discussion, the remaining things will be discussed tomorrow. So from my side, I think that is over. Muskan, anything else from your side?
Yes.
So if all the participants allow, then we can formally close the today's session.
Okay, sir. There is one question.
Yeah.
There is one question. One participant asked question: what is 6 low PN related to IPv6?
Sudhakar ji, your voice is breaking.
Okay, sir. How 6 low PN is related to IPv6?
Acha, low PN 6. So as I told you, this is basically a protocol, and 6 low PN basically, as I told that it is a IPv6 low power wireless personal area network, and it is very popular standard for the wireless communication. And basically, it enables the communication using the IPv6 over the IEEE 802.15 protocol, and basically it's suitable for the devices or the communications where the requirement of power is less. So definitely, when the condition is different, so what set of rules you have to follow to perform the communication? So 6 LO WPAN basically is the acronym of IP version 6 for the low power wireless personal area network. And currently it is very popular because every device is everywhere you are saving the power. So you have to develop something, you have to develop some devices, or you are going for such computations where your intention is always there to use the minimum power and maximum performance. So this is the objective. So for this, this protocol is very useful.
Yes, sir. Thank you, sir.
Sir, it was a wonderful presentation. Sessions today, both the sessions are very well.
Thank you so much. So with the support and with the supports of the audience and guests and Sudhakar, and others, they did wonderful. So today's sessions I'm just officially closing, and tomorrow at the same times, I think that everyone received the schedule. So from tomorrow again we'll start from 10 p.m. and the joining link is same. The joining link is same. So once again, thank you all for choosing this FDP, and we'll try to touch and accommodate all the topic and subject related to the IoT, AI, and other related areas. Thank you so much. Muskan?
Thank you, sir.
Thank you, sir.
you.